Hello, everybody. You're more than welcome to today's session, which is entitled "Can we defossilize chemicals and materials? Fact or fiction?" So my name is Lorraine Byrne. I'm the Executive Director of the Advanced Materials and Bioengineering Research Centre, which is headquartered here in Ireland in Trinity College Dublin. And it's my great pleasure to open the session today. In his opening speech earlier this week, or last week, the UN Secretary General, Antonio Guterres, made a very provocative statement that humanity had opened the gates of hell with respect to climate change and the environment. And this is accompanied by an urgent call to arms for the development and of technology to accelerate and move away from fossil fuel consumption and cut global emissions to ensure that we achieve our target of no more than 1.5 degrees increase in temperature. In today's session, we're going to examine the challenges and opportunities associated with achieving net zero with respect to the manufacture and consumption of materials and chemicals. Materials have a complex relationship with sustainable development. It could be argued that critical raw materials and advanced materials have been a driver for economic growth since the Stone Age. Critical raw materials such as lithium, rare earth elements, and gallium are essential for the transition to renewable energy, transport and the digital economy. The use of plastic packaging within food and the medtech and pharma sectors have revolutionized our ability to prolong food shelf life and prevent infection. Conversely, the impact of this intense materials consumption on climate and environment is clear, with the chemical industry alone accounting for 10% of the use of fossil fuels, emitting some between 3 and 5 gigatons of carbon dioxide on a year. The OECD have estimated that there is 13 megatons of plastic waste in the seas and oceans, and a further 109 megatons is accumulated in rivers. So enshrined within the UN Sustainable Development Goals, there's clearly a global imperative to decouple materials consumption from economic development, with this requirement setting the direction for the majority of research and innovation in this field. Our four speakers today will discuss some of the key issues in developing non-fossil-based carbon sources for sustainable development. Professor Michael Morris, who is the Scientific Director of the Amber Centre, will talk to the challenges of a net zero carbon industry and the role of circularity. Dr. Marty Rowland from Third Leg Consultants will address the need to equitably capture socially created wealth and give nations' citizens primary stakeholder status when it comes to implementing and paying for low carbon or circular economy advances. Dr. Philippe Jacques, who is the Managing Director of the Energy Materials Industrial Research Initiative in Brussels, will talk about the European Advanced Materials Initiative 2030 and its ambition to shape both policy, research and deployment of materials technologies within Europe. And Dr. Ulfa Kelkar, who is the Director of the Climate Programme in the World Resources Institute of India, will talk about the economic, socio-economic impacts of low carbon and green technologies for a large developing country. Each of the talks will take 25 minutes, and we will have 5 minutes at the end for questions of each talk. So I would encourage people, if they have questions for the speakers, to please post them in the Q&A function of the Zoom link. Following the talks, we'll have a 5-minute comfort break, and then we will have a panel discussion, which is chaired by Mr. Kevin O'Sullivan, who is the Environment and Science Editor for the Irish Times and formerly the Editor of the Irish Times. So please use the Q&A function to insert questions. If we don't get to the questions following the talks, we will compile them for use in questions which Kevin will use for the panel session. So with that, it's my great pleasure to introduce Professor Michael Morris, who's going to talk about the challenges for a net zero carbon industry and the role of circularity.
Okay, thank you, Lorraine. I'll share my screen. I hope everyone can see that. Hello?
Screen.
Okay, can you see the screen?
Yep.
Yeah.
Okay. So first of all, I'll give you a very brief overview of what I'm going to talk about. But before I start, I should actually say I'm not a climate scientist. I'm not even an ecologist. I work with plastics, and particularly plastic films, and there's a couple of examples here of how we might use plastics to create new electronic devices, new semiconductor devices. But more recently, I've been involved in looking at plastics and their circularity, and I'm actively involved in writing ISO standards that should herald greater clarity on what we mean by circularity and how we measure it. So very briefly in the talk, given my very top-down view of what I'm going to do, I'm going to talk about the effects that materials, and particularly our modern technologies, which are all based around material science, have had on the environment, etc. If we are going to defossilize, one of the key targets is to defossilize the petrochemical industry. So defossilization isn't just about energy. It's where we get some very basic materials from. If we're not going to get carbon from fossil fuels, where does that carbon come from? Where could it likely come from, which could actually maintain or improve a healthier environment for the planet? I'm going to very briefly talk about the challenges and some of the objectives and the impacts of them, and give a perspective on what's needed, and emphasize the links to the research that's needed and the social, environmental, and economic change that offers the greatest challenges. And my fellow speakers will emphasize some of those facts as we go through. So if we think about carbon, it was the start of the Industrial Revolution towards the end of the 1700s, which has led to our incredible reliance on carbon for generating the massive world economy that we've got. Currently, over $100 trillion drives out the global economy, and most of this mediated about materials, and particularly the fossil fuel that produce many of the materials or are involved in the production of many of the materials that we work with. So if we look for a point of inflection around 1770, that is the kind of point where we moved from a feudal system into an industrial-based system. And this shows the kind of real start, the real accelerant for this was the invention of the flying shuttle. And this was just a tool for throwing across a weave. So as the weaves go up and down in a frame, this could be thrown across from one person to another, catching it as fast as they can so that you could weave faster and also make bigger sheets. Now that became automized, which meant that we needed cotton, wool, flax transported, which led to the transport revolution. We needed the chemicals to treat, process, and dye those fabrics. And all of a sudden, we had a burgeoning chemical industry. And that's what's really taken off. And that is the cause, the mass production, the mass consumerism associated with the Industrial Revolution has driven the environmental damage that we have. But we can never forget the incredible benefits that this industry has brought, this Industrial Revolution has brought to us. And if we just plot that period of time around the Industrial Revolution, we've seen incredible social benefit. So all the way from the late 1700s to the present day, by the last 2 years because of COVID, we've seen an increase in life expectancy. Industrial Revolution has also led to our ability to feed increasing numbers of peoples on the planet. So we've seen an explosion in terms of the population, which may, and we're all hoping, will peak around 10 million, but maybe not. And we've also seen an incredible social value in terms of reductions of the number of people in abject poverty. So we've seen people living longer, more people living, and more people enjoying comfortable lifestyles. And that, of course, has driven change. Now, while we might identify climate change as the critical issue to address environmentally, climate change isn't the problem. Those numbers of people and the way we live is the problem. And so if we add up greater populations, greater life expectancy, less poverty, and the CO2 emissions that are caused, and our reliance on fossil fuel, that has obviously led to the environmental problems that we see. So we've seen global figures in terms of climate change over a degree in the last 100 years. We've seen massive losses of biodiversity and wild space on the planet. And that's had the impact that it has. And those three things, biodiversity, climate, and free space, are often seen as separate problems, but in fact, they're all a manifestation of the industrialization driven by our need for materials and driven by our need for products, which have changed the world. So even when we start looking at changes in the world since 1700, the center graph kind of illustrates the loss of wild grasslands and the loss of wild forestry, which are clearly accelerating the climate change that we're seeing at the moment. The counter figure of that, of course, is because we've got more people, we need more land to feed them, so we need more grassland and more crops. And as you can see, that we need more grass for grazing than we need for anything else. But so climate, diversity, and temperature, and wild lands, they're the three manifestations of industrialization. With all the social change they've brought and all the social benefits they've brought, that is the price that we pay. If we look at what oil and gas is used for, and I won't go into these figures too much, I guess everyone will know them. About 60% of all the petrochemicals we use are used in car transport and energy. Around 10% of the oil is used for cement manufacture. Around 7.5 billion tons of coal are used in steel manufacture. Around 15 to 18% of oil and gas are used for chemicals and plastics. And the rest of the useful materials are asphalt, propylene, and kerosene. So although we kind of associate the fossil fuels with heating energy, around 30% of them are used to drive our economies and our industries. And that's the difficult problem. The other problems that we have, we can affect change by affecting the use of renewable energy, given various parameters such as energy density, which we probably can't replace from hydrogen or renewable electricity. So there are some problems we can't get over, but we can address 50 to 60% of the fossil fuel problem for that, but we still need an enormous fossil fuel to drive industry. And if we look at the 2050 type period of change, we need somewhere around 1.5 billion tons of carbon to defossilize industry, chemicals, and polymers. Right? So recognizing what we use these things for. And just to pull a figure out of the air for how difficult and what a challenge it is that for polymer production, for the production of plastics by 2075, the current growth rate, which we're not seeing slowing or decreasing, we'll need 1 billion tons of carbon alone to meet our demands. If we think about what those fossil fuels give us at the moment, about 3% of all of the world's fossil fuels are used to make pharmaceuticals. The plastic industry is a huge consumer, and by 2050, 2060, we expect that just the emissions associated with plastic production will be 20% of all global emissions. Around 0.9 billion tons of oil are used in the construction industry, and clearly as our population increases as our lifestyle changes, construction is going to grow as a sector. The semiconductor manufacturing industry, and we think of that being quite a clean industry, now exceeds car manufacturing in terms of its output. So there is a desperate need for us to find other alternative sources for these chemicals. If we're going to defossilize and we're going to get rid of fossil fuels in this petrochemical sector, the material sector, which we all rely on, we're going to have to do something very significant. And these are the figures that we have from a recent OECD report before last Christmas. They've looked at what's happening in the plastics and projected them through to 2060. So in 2020, we produced 460 million tons of plastics. By 2060, you can see that's looking at to be about 1.2 billion tons of plastics. There's no saviors on the horizon. Biochemicals and bioplastics are a very small fraction of that, somewhere between 0.5 and 1.5% is kind of accepted figure. And even when we look at things like recycling, by 2060, only 17% of the world's plastic is likely to be recycled. So we're going to carry on needing to manufacture these plastics at an enormous rate and an enormous amount to maintain the current technology and the current lifestyles that we have. So there isn't a quick solution. The circular economy, which might be used to boost things like the lifetime of products and the circularity of them in general, is really being very slow in being advanced. So is it practical to decarbonize industry in line with the IPCC targets of 2030 and particularly 2050 and 2070? Well, all the indications set against this suggest not. So if you have a look at the bottom figure, this is just a plot of the material extraction in the current linear economy that we have. So, and it's looking at the total tonnage, gigatons of materials that are being extracted from the planet and used to make products and materials. And what you can see is, unless we do something different, that indicator of economic activity is almost going to double between 2016 and 2050. And the fact that we're extracting these things implies that we're going to need oil to make the products and oil to convert these products into what we want them to be. And if we have a look at a publication by the Science Based Targets, it talks about essentially two issues. That, first of all, if we're going to get to net zero by 2050, companies, industry must reduce its carbon footprint by at least 90%, which is a challenge domestically, but industrially, in the current world, it's even more difficult to see that. And we also must take action to reduce emissions through things like carbon capture. So that's the challenge that we have. Where do we find the carbon from? And how do we change the way we do things to be more consistent with a healthy planet? So where does that carbon come from? It's worth again stating that currently fossil fuel that's around, we generate about 40 gigatons of carbon dioxide emissions, about 55 gigatons of CO2 equivalent. So that's the NO, fluorocarbons that are released by largely the semiconductor industry and everything else added up. So a gigaton of carbon dioxide, we're around 42, 43 at the moment. So we're thinking about that a gigaton is the mass of all the land animals in the world other than humans. And even more frightening, I think this tells us how we've damaged the planet. There's twice as many people as there are land animals. We know that offsets won't work. If we're going to offset 40 gigatons, that's about a surface area of 5 times the Amazon rainforest. We can't going to get carbon from arable land because we have a food shortage. And in fact, the only way that we can grow enough food to feed the world at the moment is by the use of fertilizers, which are essentially fossil fuels, since they're largely generated by gas and oil, because they increase the crop yield by 2.5. As it says here, that fossil fuel, about 1% of all fossil fuel is used to make fertilizers. So we're not going to use plant chemicals, and I've got a slide on this in a second. It must also be sensed that if we're going to generate carbon from non-oil sources, which is very easy to deal with, and we have existing technology and have had for over 150 years, we need renewable energy. There's no point trying to make chemicals without that renewable energy. So we're probably going to increase the demand for energy by a factor of 1.5 or twice. And at the current moment, worldwide, if we're thinking about this as a challenge, only 5.5% of global energy is actually renewable at the moment. But we do have these terrible contradictions. If we look at land scarcity, this is a report from the IMF on the top left, showing where we are buying up arable land or land for cultivation across the world. Africa is by far the biggest source. About 60% of all the available land for farming is in Africa, followed by South America. And you can see the values of the land that they've put on it. So clearly, where we have tropical or cold lands, there's no value in the fields. But as we go towards this very rich temperate zone across Africa and South Africa, we see that's where we should be cultivating. And the only problem is that those cultivation lands align exactly with our forestry, and particularly our rainforest, and particularly amongst the wild grasslands, which are needed for animal migration, which is the bare minimum we need for biodiversity. So we have this terrible contradiction that we have such a high population that we're running out of space for us to grow things. And it's that's putting pressure on the wildness, which drives biodiversity. So there is a terrible land scarcity, and asking that land to support, or thinking about that to support carbon production as organic chemicals that are farmed, is not going to deliver the kind of change that we need. So some simple chemistries, which I feel as a chemist I should maybe talk about the kind of things that we're talking about. Petroleum and gas, you can see why they're so valuable and they're so easy to use. They have very high carbon content. So if you want to make them into things, to chemicals, to plastics, to other materials, they are fantastic because they not only have high energy density from the carbon to carbon dioxide reaction, they also have carbon and hydrogen, which are the building blocks of modern organic chemicals, be them pharmaceuticals, be them plastics, be them coatings, or what have you. So they are the two best, right? Without a doubt, they are the two best processes. Wood is probably the third in line as biomass. Grass is probably worse. Wood's slightly better because it's got more hydrogen, but they're about half the carbon content of oil. Carbon dioxide is a source, but it's a very difficult source to work with because those carbon-oxygen bonds are very strong and very difficult to break and turn into other products. where do we get our chemicals from? So we take this 10%, 15% of all the oil and gas and coal dug up, and we reform it and crack it. So we break it into smaller molecules, and then we react those molecules to give us more double bonds, which creates reactive species. Methane, we get all our chemicals via what's called syngas production. So the methane is converted to carbon monoxide and hydrogen, and that's the basis of making methanol, ethanol, propanol, and eventually the polymers and the organic chemicals that we see. If we think about wood, how are we going to use this? We don't really have the technologies super well developed, particularly in the large scale. So we can just try and make syngas out of it. But before that, we probably need to pyrolyze it to get rid of the oxygen and improve the carbon and the hydrogen content. And then there's bioprocesses, which are still very much in the development phase and not consistent at the moment with large scale manufacture. Carbon dioxide as a product, well, we have lots of that. 500 ppm of the Earth's atmosphere is carbon dioxide, and we're adding to that every year. That's another indicator that's grown, of course, as the world's warmed. But that needs very significant, because of those very strong bonds, it needs very significant energy and hydrogen input, which is a way of transporting energy. So the technologies are possible, but they're not ready yet. So we have to get this carbon dioxide. And the way that's often spoken about is CO2 capture. And we have to be very careful that there's two forms of carbon dioxide capture. There's one which is called point source capture, where we take flue gases from combustion plants, from cement plants, from glass manufacturing plants, very high in concentration of carbon dioxide. We trap that CO2 by compression, and then we can either transport it or pump it into the ground. We could use it. We use very little of it at the moment, apart from things like soda. But there is this effort that we could do so that every turbine, every energy source that produced high carbon dioxide was compressed and then transported and either stored below the bedrock or used for other processes. The types of sources that we're looking at here are combustion plants, turbines, cement plants, iron manufacture, and they produce huge amounts of CO2. And this technology, kind of as it shows on the right, is under development and is scalable at cost, of course. So looking at this technology is probably going to cost of the order of $4 or $5 trillion worldwide if we're going to clean up these point sources. So that's the first use. The second way to remove carbon is called direct air capture. And that is exactly what it says on the tin. It's the capture of carbon dioxide from the atmosphere. So this 400 ppm. And it's very clever technology. It has been scaled, not to full scale as we'll talk about it in a moment, but it is scalable. And this is a way of really reducing carbon dioxide in the atmosphere. So this is a way of addressing the current problem and trying to reduce the burden on some of the technologies we might have to reduce. So here, instead of just using simple gas compression, where we liquefy the carbon dioxide and separate it from other liquefied gases, here we absorb it on a material. The air passes through it, we take the CO2 out, we get pure air out. The CO2 is then stuck on the material that we've chosen, and then we absorb it to separate it out. And there's a couple of illustrations here of how we might adopt that technology. And it is under development. Iceland has, or did have, the largest CO2 direct absorption plant. And it absorbs about 4,000 tons of CO2 per annum, which sounds quite a lot. So you remember that we emit 40 to 50 gigatons of carbon dioxide. So even if we look at a country like Ireland, we probably need thousands of these plants costing somewhere between $300 to $600 billion at the current price. So there is an economic issue with this technology in that at the moment, it's unaffordable, right? So whether that be a small country or a large country, to make very significant inroads into our CO2 problem, at the moment, the economics don't work on it. And even if we go to the last slide and we look at carbon capture, the current carbon capture prices is about $100 per ton. And that can make the manufacture of things like cement and iron non-competitive. So we've still got to work very hard technically to reduce these prices and make these technologies not only effective technically, but effective from a commercial point of view. And then, as I said before, a carbon dioxide could be used in combination with hydrogen generated from renewable energy and the electrolysis of water, could be used to make the chemicals that drive our technology at the moment. And was this is well underway, so here's a plan for a plant that the company Holdo Topsoe are building for really using carbon dioxide as a commercial type route to these chemicals. So this work is all underway. The other way to generate carbon is from biomass. I'm not going to center too much. I'll just use wood as an example, but we have biomass from waste farming materials, from our own waste food. We have biomass from things like seawood. So there is a variety of sources, but probably the easiest to think about is wood. Forests sequester about 11 to 20 tons of carbon dioxide per acre. And if we think about the reason we're in a period of afforestation, is because it's responsible for 10%. We could reduce our global warming figures by about 10%, which is very significant. So forests are often described as the lungs of the world. That's not completely true. But they are a very significant contributor, and deforestation is obviously very significantly affected global warming. But if we think about managed forestry, and I've got a couple of figures here from the US EPA looking at a particular site, looking at the felling of roundwood, which is the complete tree chopping down, and then the thinning, which is actually environmentally very, very good because it exposes the forest floor to light, which allows bushes and other crops to grow and helps insects develop. So very good for biodiversity if we continually thin and manage the forests we've got. But even by thinning, so this is without loss of forestry and forest recovery, we can harvest 30 tons of wood per acre. And if we think about a wood, 1 ton of wood is half a ton of carbon, we could do some figures which amazingly show that we can get 2 billion tons of carbon from improved forestry by just covering about 0.1% extra of the Earth's surface. But these things need very careful monitoring. This is very much a ballpark figure. So it could be 1%, but it's a very low figure. We're not talking about rebuilding the Amazon rainforest, which is about 4% of Earth's coverage. We're talking about a fraction of that to generate enough carbon to drive our current technology. Problem with that is it's 2023 and forests take 50 to 70 years to grow. We also have to think about what that forestry looks like. We're not talking about monocultures, we're talking about biodiverse tree species, etc. There's a lot of conversion needed to make these grow. But again, that technology to go via pyrolysis, which is essentially heating something in an oven, through to biodiesel and then onto chemicals is well proven. But yet it's a small market. So current market is about 500 million. worth, and we need to grow that by a factor of 10 to start making a significant contribution as a replacement to oil. So again, an economic challenge, but again, this isn't going to change our lives very significantly. All right, so at that point, I guess it's time for me to close up, and I'll finish with some remarks. We've got to remember the business as usual is not possible. We can't find technical solutions, and I don't believe we can find technical issues unless we really think about how those technological solutions interact with the planet. Somewhere along the line, we have to reduce our demand for chemicals and materials, enable to us to reduce our reliance on fossil fuels. Thinking about the globalization and the maximization of defossilization while still producing carbon is largely an unaddressed issue at the highest levels, and that must be thought about considerably. Technologies are available. We do need new and improved technologies. There are a myriad of solutions, including the circular economy. The circular economy should be one of the greatest solutions. This way of living as if we were on a spaceship where we can only take and give back to the planet in an equilibrium. But it is a real challenge, and I just finished with a figure here which kind of frightens me. At the current moment, because of our modernization, we make 1 trillion semiconductor chips every year. And each one of them releases at least 1 kilo per gram chip. And that's only going to increase. So whatever way we look at the ICT figures, and again, in another 30, 40 years, semiconductors and electronics are going to be contributing 20 to 30% of global emissions. So when we think about what we want to do, we're so reliant on communications, we're so reliant on the computer chips and cars and airplanes and everything we have to think about that. So it's not just a technological problem. It's not an economic problem. It's a huge economic problem, but it's not just that. It means that society must change if we're to protect the environment. And I think some of my other speakers will follow up on those issues. So with that, I'll finish, and thank you very much.
Thanks, Mick. There's just one question in the chat, which I think you've actually already answered, but it's if we need carbon to match our current society wants, how will the goals be met? I might paraphrase that and say, do you think that the technologies we have today are sufficient to meet that 1 billion tons of carbon requirement?
I think the technologies in combination could address that problem. Could they address it now? It's something else that it's given the will and given the money, but it's probably a multi-trillion solution, and that's the barrier is raising the funding and raising enough of a public interest to actually drive that kind of investment. But it is going to take that kind of investment. The core technologies, the methodologies are all there, generating hydrogen, be it electrochemically or photonically. Right, we have all of the core technologies. They need scaling, they need improvement, they need to be driven to their maximum efficiency if it's going to be possible, but the core technologies are there.
Right. Thank you for that. So we move on to our second speaker, who is Dr. Marty Rowland from Third Leg Consultants. And he's going to talk about the need to equitably capture social created wealth and give nations, citizens, primary stakeholder status when it comes to implementing and paying for low carbon or circular economy advances.
Well, thanks. You can hear me, right?
Yeah.
Okay, yeah. My name is Marty Rowland. I'm with Third Leg Consultants. When I'm not doing that, I'm on the board of the Henry George School of Social Science. I'm an editor of the American Journal of Economic Sociology. I'm a senior fellow in the Asset Leadership Network. I do work with Mick on the ISO circular economy, and I do work at New York City Parks Department. I've been doing environmental engineering for about 46 years. And what I'm going to be covering today is picking up where Mick left off and describe the social and economic issues that have to be addressed if we're going to go to a de-fossilized economy. So I'd like to start out with Larry Fink, who's famous for putting together programs for environment, social, and governance. So he said that the BlackRock is not the environmental police. Government policy, technological innovation, and consumer preferences will ultimately determine the pace and scale of decarbonization. So I'm going to come back to Larry because I'm going to kind of critique what he says here. But I find a source of moral force from these three people. And let me introduce the first one, Henry George. The center person is Elinor Ostrom, and on the right is Kate Raworth. And just to give you a little overview of what these people stood for and what they said, Henry George said that the world's resources belong to everyone, born and to be born. Nobody's labor created those resources. Those who have a private land and other resource privilege have an obligation to those without that privilege. And then Elinor Ostrom says that there's more than two types of ownership. There's private and public, but she identified what she calls the common pool ownership, which has been around for millennia, sustainably and equitably caring for resources and other shared goods. It's a natural law that these goods and systems conform to a set of sharing principles. And then Kate Raworth sees an upper and lower bound within which humans safely interact with natural systems. She calls it a donut shape. The upper bound is a limit beyond which life in itself is threatened, as with pollution. And there's a lower bound, which is the minimum below which humans cannot survive, let alone strive. So that's I think, a very good statement of the issues that we've been discussing here so far, is finding that life is in that donut. So I'm going to be talking about three propositions and throughout my talk, but I'm going to start with the first one, is that the circular economy includes a manufacturing symbiosis as well as a urban symbiosis. And currently, the focus within the ISO activities for circular economy have been focused on manufacturing, and we can see a good reason for that from what Mick had described. But I think we'd be in error if we didn't appreciate what I call the urban symbiosis. And we'll be touching issues such as wealth and land value as I proceed. The second proposition is the movement to a low carbon economy must be at the behest and consent of an informed citizenry, lest life, societal transforming choices become a devolving series of authoritarian, best of equally bad alternatives. And I think that's the conundrum that Mick was expressing. But I'm going to close up with the third proposition, which is proper forestry can no longer be an afterthought or a private matter, but rather at the heart of a low carbon waste system of common pool resource management. carbon sequestration, biodiverse habitat, water and air purifying environment, and not the least, safe from urban sprawl. So these are the 17 United Nations Sustainability Development Goals. I'm going to be talking about 7 of these in my talk. I'm going to be talking about poverty, decent work and economic growth, industry, innovation and infrastructure, reduced inequality, sustainable cities and communities, life on land, and partnership for the goal. So let's start off with the first proposition about manufacturing symbiosis and urban symbiosis. So in the circular economy efforts, we focus on manufacturing of parts, computer chips, whatever the manufacturing is going to be involved in. So I identified what is called a life cycle continuum, if you understand what that product is all about. And I plot this continuum starting with newly produced materials down to raw waste to raw materials, and you go from birth to end of life. So the whole life cycle of a product could be seen going up and down this this line that's on a downward slope. The significance of this is that the product could be made with low carbon, but if you're in a situation where we are now, introducing low carbon materials to something that's already working is probably the direction that we need to get to, because we're not going to stop everything and go into a low carbon type manufacturing. So in this life cycle, we have a product would be disassembled, components replaced, expired content disposed, but there are also going to be scavenged parts for remanufacturing. So this is the manufacturing life cycle continuum that's important for a low carbon environment. Importantly, in my opinion, the urban symbiosis is not well understood or appreciated. And I'm going to start off with tangible assets, tangible infrastructure, such as the high-speed train. You could be talking about water and sewer systems, buildings, things of that sort that have a substance to them. And when we talk about tangible urban infrastructure and a life cycle continuum, again, we start with the start of a cycle and you go to the point where the material gets old and out of use. So it goes to construction and demolition debris, materials recovery. So the thing that's important about this continuum is that you could expand systems such as the high-speed rail to metropolitan areas. We could go for net zero energy or low carbon retrofits. Thing to keep in mind is that we're increasing maintenance and operating costs as we go into this life cycle continuum. And then on the right here, we talk about implementing an alternate service plan, making the final years productive. I'm going to touch on this at the very end when I talk about the co-ops, the one that I live in, and the challenge for a defossilized economy, because there are alternative ways of getting to the defossilized economy. And I think serious consideration should be given to what we have in place. Importantly, urban symbiosis also touches on what's called intangible assets or intangible infrastructure, things that require trust. For example, healthcare or financial services, police departments, fire departments, things that you can't put your finger on, feeling safe. And that's what urban symbiosis and the intangible urban infrastructure is all about. And you have the start of the cycle, and you have a periodic performance review. So this is not an object that's wearing out, but you do have increasing pension costs, for example, when you have a very effective government or public services provision. And I've got a different y-axis here where you have higher per capita expense. So as your increased costs go up, you have to have the resources for that improved service, but there's always a challenge of making major institutional changes. And if we're going to go to a green or low carbon equitable governance, we need to keep that in mind. So all these factors play into that. Also, there's a third type of urban symbiosis, and this has to do with the urban land value. And if you look at this photo, I think first off, I think a lot of people would say, yeah, it's great that I can find a parking space, but if you think about the waste of land value, you have all these tall buildings on one side, and then the other a parking lot that's probably taxed at a very low rate. Otherwise, the parking lot owner couldn't exist. But there's so many other ways of handling the land value, and that's what I was going to get at in this fourth figure here. The life cycle continuum, looking at land value and going from the current, which is the typical type of property tax system that's in existence in the United States, split rate property tax to a land-only property tax, and then periodic land assessment, a very important factor in this type of revenue generating system. So as you move up this curve here, this line, you have increased public revenue, because what you've done is increase the acreage of land back on the tax rolls, because you're placing the burden on people who are speculating on land or people who are using land at a very low value. Importantly, and this is going to be coming up in some slides after this, being able to capture that additional revenue is important to pay for the tangible and intangible services, which may include increased costs because we're going to a low carbon economy. So let's go to the second proposition. The movement to a low carbon economy must be at the behest and consent of an informed citizenry. Community engagement is a very important factor in this, and I'm going to be talking about what's common to to all management systems is this idea of plan, do, check, act. You plan something, you might implement it on a small scale, you check to see how well it's doing, then you act in a final way because you've checked to make sure that it can be done. And this is relevant if we're going to be doing, as Mick was pointing out, going into a low carbon economy. That do step is the big hurdle that we're at right now. Now, if we talk about the ASTM 3210, E3210 infrastructure management, which is a type of a management system, the authority, which could be like a mayor, would seek citizen stakeholder consent. This would be something that the mayor authority would choose to do because he knows that the citizens want to have a say in what's going on. There would be periodic performance reviews, might be on what's our carbon footprint, how are we doing on our low carbon economy measures. You look at the public revenues and outlays. There's 2 public meetings. The second meeting held after the citizens have had time to digest the impacts and the costs. And the important factor in this type of management system is that if the authority doesn't perform, it's pretty easy to elect a new one in the upcoming election cycle. So this is a continuous improvement diagram, just showing that as you do more of these plan, do, check, acts, you get experience on what's important and how to keep that movement going. When we talk about circular economy, most people look at material flow, and you see on the top, you got virgin materials, you got waste on the bottom, and in the middle, you got reuse and recapture of materials so that you minimize the disposal. Well, what I'd like to point out in this talk right here is talk about the circular urban wealth flow, and I'll get to that by pointing out in this shaded area the authority, which could be the mayor, the city's revenue goes to increase the infrastructure for capital assets and services. And this is the type of thing that 3 standards look at that are available. The ISO 55000 standard talks about asset management. E3210 talks about infrastructure management. And the ISO 37120 talks about performance measures for cities. So this shaded area talks about infrastructure provision. So money in hand goes to improve the assets. So looking at it another way, it's the infrastructure, assets, and services, increasing land value. And then if you look at the land value return, we see that the land value is increasing the provisioning revenue and going from land value, urban land value to the total land value. We have a figure called A, which is be the land value tax. It doesn't tax the whole land value, but it's an increment that's sufficient, and ideally would be sufficient for the C costs. And there's a reason why this is relevant. It's talking about an inherently circular process where you provide the services, the tangible and the intangible services, increasing the land value because people like to live in safe areas. They like to live in areas where the education's high, the environment's clean. So you identify what's called a land value return. So the reason why that's important is that in most cities, revenue is not generated by land value. In contrast, the land values have a split tax source. So they tax land and buildings. In a land value taxing regime, you don't tax the building. But if the revenue is short, you've got other revenue sources. And the only thing that can replace land value would be taxes on labor and capital. And we all know about income taxes and businessmen's paying tax on capital. So if we could get away from having taxes on labor and capital, we could reduce poverty, spur production, and increase employment. So this is just a demonstration that there is a circular economy in the urban symbiosis. So the third proposition that I'm going to be talking about, and then we can go to questions, is that proper forestry can no longer be an afterthought or a private matter, but rather at the heart of a low carbon waste system of common pool management. So forestry, low carbon use, is it more about social control or concern for the environment? So I'm bringing up some facts and figures to question what the low carbon economy is all about. Is there an element that there's a element of social control being requested, let's say. So man-made CO2 emissions, I heard Mick say is something a little bit more than this, but this is the figure I got, 36.8 billion tons, which is a gigaton. China emits about a third of that, and the US about 13.5%. Methane is emitted naturally and in production, transport, and the use of natural gas. Equivalent CO2, if you need to understand how that's derived, there's 13.7 billion tons. I can explain that if you need to. Then the number of mature trees is estimated at 3.25 trillion, with each sequestering an average of 48.5 pounds of CO2. We come up with 71.5 billion tons of CO2 ideally sequestered. And then oceans, we can't forget oceans that hold 150 times more CO2 per unit volume than air. It's estimated that 10.9 billion tons is sequestered in that way. So if you look at the four figures I just expressed, what you come up with is a excess CO2 sequestering capacity. Yet the atmospheric CO2 concentrations continue to increase. So the question is, what's going on with these numbers? It could be that the trees are not where the CO2 is being emitted. That would explain for the additional CO2. Perhaps the tree estimate is inflated. Perhaps wildfires, clear cutting, tree plantations, and the sequestering capacity is inflated. Importantly, in my opinion, there's annual meetings of world leaders who pledge to reduce CO2 emissions, but there's no such meeting to pledge for afforestation. And I guess I'd have to ask why not? And hopefully it's not because of social control, but you have to wonder, why isn't there a global meeting about afforestation? Consider that Canadian wildfires in 2 months this year emitted 1.5 billion tons of CO2. This is 3 times what Canada emits every year from burning fossil fuels. Brazilian rainforests have found to be a net emitter of CO2 from clear cutting and slash and burn. And then Europe is receiving a large amount of forest products from Romania. It's estimated 306 square miles out of the 1,100 square miles of Romanian forests, which would suggest that in 2 or 3 years, all the forests in Romania would be devastated. To add to that, Europe also gets 31 square miles of per year of forests in North Carolina and Virginia. So I guess we'd have to calculate how many more years that there's forests in those 2 states. And then 3% of all trees on Earth are in industrial forest plantations in those states there. And 70% of those get state subsidies for removal. So clearly the trees are not being valued by their capacity to sequester carbon. I do have to say that a nascent effort is underway to create tiny forests, and where soil conditions and other factors are measured to ensure an effective canopy for all the reasons people and nature value forests. Perhaps once all the tiny forests and other vegetated spaces are under a monitoring regime, perhaps some truth will be revealed about the CO2 balance that I laid out here. But I will have to say that it seems odd that we would build carbon removal machines while we subsidize the removal of natural methods of doing the same thing. It's clear that trees are underpriced. So to conclude my talk, the question is, can we defossilize chemicals and materials, a factor fiction. So I say that we probably can. It's going to be tough, but at what impact and what cost? If CO2 emissions are causing a warming planet, what part do human emissions play? Human-caused emissions. So there is still an open debate about what the human-caused emissions percentage is. Well, the question is, will some authoritarian direct our low-carbon future, or will people withhold their consent? Here in Queens, New York City is forcing middle-income co-op owners to decarbonize energy supply to go all electric, but there's a movement against it. There's a local law 97 that requiring that that CO2 be reduced by 40%. So they're going after these buildings that are about 60 years old. And I brought up the point about tangible infrastructure that could be glided to their end use, that perhaps getting rid of all the gas stoves is not the most efficient way, or maybe resilient. I guess one of the questions is, what's the price of the electricity going to be when we go electric? And I like to finish with Larry Fink, go back to his statement about BlackRock not being the environmental police. He talks about consumer preferences, but notice that he leaves out citizen and taxpayer demand and willingness to do that. This coming from the head of a company that would control the air we breathe and sell it if it could. And I make that not to be funny, but if you think about it, this is not much different than buying up single-family homes and apartments and leasing them and selling them at inflated prices. The question is, where's the intergenerational wealth that's not created? Clearly, it's not going to the people that need it. Nationwide, institutional investors own 3.8% of the 15.1 million single-family rentals, and in Charlotte, North Carolina, it's 20%. So, depending on the city that you're in, these corporate landlords are taking over a resource that we're taking over a resource, but they're buying the land, which I pointed out, perhaps they have an obligation to do something other than capturing the rent. So that was my my talk. I'll be available for Q&A at this point.
Thanks, Marty. If there's any questions, please include them in the chat or the Q&A section. I have a question for you about the challenge around having an informed citizenry for decarbonisation. And you're right that they're so necessary in driving it forward, but how informed do you think citizens are about the complexity of materials and decarbonisation? And as scientists, how can we do a better job at improving that?
Yeah, I think that's the challenge, is to explain it in very clear terms. I think Mick expressed it very clearly that it's going to be very costly, and it's going to take a lot of resources out of things that people are used to and are comfortable with. I think if you don't involve them early on, I could see a major social event, revolution of that sort. I mean, this is life-changing, so it's something that needs to be addressed seriously.
Okay, are any other questions from the audience? Nothing coming up. Okay, well, thank you, Marty, for that presentation. And if there's any sort of questions, we'll address them in the panel session. So our next speaker is Dr. Philippe Jacques, who is the Managing Director of the Energy Materials Industrial Research Initiative based in Brussels. And Philippe is going to talk about the European Advanced Materials Initiative 2030 and its ambition to shape both European policy, research and deployment of materials technologies across the continent.
Yes, good morning, good afternoon, or good morning, depending where you are based. Thank you very much, Lorraine, for this kind introduction. So let me share my screen. Is it okay for you?
Perfect, thanks.
Okay, perfect. Okay, so as Lorraine introduced me, I'm Philippe Jacques. I'm the managing director of EMIRI, which is an international association based in Brussels, which is advocating for advanced materials as a key enabler for bringing technology solutions to the issue of the global challenges we face, especially by developing solutions for clean and sustainable energy and mobility applications. So we are gathering roughly 60 organizations, industry, research organizations, and different associations which are also active in the field of this clean and sustainable energy and mobility. And where the main purpose of the association is really to develop and co-construct also with the policymakers at the European level, really what are the appropriate solutions and the appropriate actions really to be taken regarding the, especially on the research and innovation policies. So what I would like to cover today, and I will come back to something which is probably more technical than the previous speaker. So I would like really to provide some last indication of where we are regarding the objective of this net zero transition, net zero emission regarding energy. I will focus also a little bit on the issue which are faced by the chemical industry, really to conduct this transition to reach the goals of the COP in Paris. Highlighting one possible way forward and then focus on the key enabling role of advanced materials, but also addressing a few more high-level questions, I would say, regarding really the problem that we could face, that we could in the future go from a dependency on fossil fuels to a dependency on critical raw materials, and also on be dependent of other regions in the world, really regarding the technology supply chain, so technological sovereignty aspect. So what I wanted to do here is first to share with you the conclusion from a very recent update of that was issued by a report that was issued by the International Energy Agency, which is this net zero roadmap, global pathway to keep the 1.5 degree goal in reach. So the case really for transforming the global energy system in line with this 1.5 degree goal has never been stronger. That's the good news. The impact of climate change are increasingly frequent and severe, and that was already mentioned. And scientific warnings about the danger of the current pathways have become stronger than ever. It's true that the global carbon dioxide emissions from the energy sector have reached a new record in 2022. But the speed of the rollout of the key clean energy technologies are such that now the International Energy Agency projects that demand for coal, oil, and natural gas will all peak during this decade, even without any new climate policy. So this is very encouraging, but even if this is not nearly enough for the 1.5 goal. So positive developments over the past 2 years include, for sure, solar PV installations deployment and also the electric car sales, which are really in line with the milestone that have set out for them in the previous report that was issued by the International Energy Agency. But even if the innovation is already delivering new tools and lowering the cost, there are still important need to do much more, notably on the infrastructure. So today, much of the momentum was focused on in small modular clean energy technologies like solar PV, wind, and batteries, as I was mentioning. But these alone are not sufficient to deliver the net zero emissions. It will also require large, new, smarter, repurposed infrastructure networks, large quantities of low emissions fuels, technologies to capture CO2 from smokestacks and directly from the atmosphere, like it was mentioned already before. We will require also more nuclear power and large land areas for really deploying the renewables technology. Electricity transmission and distribution grid also need to expand by around 2 million kilometers each year until 2030 to meet the needs of the net zero scenario, net zero emission scenario. And technologies like carbon capture, utilization and storage, hydrogen-based fuels and sustainable bioenergy are totally critical to achieve the net zero emission. So that's very aligned, I think, with what was already shared earlier. But you see that, well, the good news is that it's still possible, but it will be really challenging. I think what is not appearing here are the amounts of investment which are needed really to achieve this transition, and not only investment in infrastructure, but also investment on social dimensions, really to make sure that this transition will not leave anyone aside. Also, if you think of all the workers which are currently still working in coal mines and so on, that will see their work totally modified in the coming decade. So all this and the same for the automotive industry, which needs to reskill totally their workers so that they are able really to maintain the electric cars, which are significantly different from the classical internal engine car. So that's for the energy sector. If we have a look at what's happening in the chemical industry, I wanted to rely and to really to invite you to have a look at this report that was issued by the Commission earlier this year, which is called Transition Pathway for the Chemical Industry. So this is the result of a joint exercise that was initiated by the Commission, but that was really conducted along with the member state, the chemical industry itself, and the different social partners, NGOs and academia, which really emphasize the tracks to follow, and but also which highlights the challenges ahead for the chemical industry. So for sure, the chemical sector has a strategic role in the European economy. Many goods that are manufactured in Europe rely on chemicals for a wide range of various functions. And the twin transition covers several dimensions for the EU chemical industry, such as a toxic-free environment, climate neutrality, circularity, digitalization, also the digital transition. All these dimensions must be addressed more or less at the same time, really, to support the resilience of the chemical industry. Just to give you a flavor of the importance of the chemical industry in Europe, the EU 27 industry, the second largest producer in the world regarding chemicals, with nearly 500 billion euro sales in 2020. It's also the fourth largest industry in the European Union, accounting for around 7% of the manufacturing output by turnover. And the issue is that the chemical industry is the third emitter of carbon dioxide emissions in the European Union, with more than 9,250 million tons of CO2 in 2021. The 2030 and 2050 legally binding climate target represent the next important step for the chemical industry, and this is the investment and the innovation capacity will be really crucial to achieve the goal of the chemical strategy for sustainability that was adopted by the Commission in 2020. This chemical industry, the CSS, or the Chemical Strategy for Sustainability, aims to provide chemicals and materials that are safe, sustainable by design, that offer new ways to produce chemicals and materials. And it's important to know that the European chemical industry is investing nearly 10 billion euro in research and innovation activities every year. And this investment and innovation will support the twin transition of our economy, but this is just a very minor part of all the investments which are needed really to implement the transition that will be needed. So the report really here presents a very high level transition pathway for the chemical industry to achieve the twin transition and really guarantee its resilience. The outcome of this pathway is a three-part roadmap, which is the result of this co-creation process with stakeholders, which identify 8 building blocks really for succeed in this transition. And one is about really the topic of today, access to energy and feedstock, which are of course sustainable and less dependent on fossil fuels. And so the main levels that have been identified are the electrification of energy supply, and also the electrification of all the chemical processes, integrated production of hydrogen with a low carbon footprint, biomass to be used as an alternative feedstock like waste, of course, and also CO2, and last but not least, in improving again and again the efficiency of the process and the resource which are used in the process. So this is just to share and to give you a feeling of really of the importance of and really of the challenge ahead. And I would like now really to introduce a very interesting initiative which is ongoing in Europe for some years already, which is named the Synergy Initiative. So Synergy is an open community which is advocating really for solar fuels and chemicals as being the new solution, the new paradigm for a climate neutral Europe in 2050. And this community gathers a wide range of different group of experts from industry, academia, and society. And really, Synergy aims at becoming a large research and innovation community initiative, really working toward the conversion and storage of renewable energy in fossil fuel and chemicals. The interesting approach of this initiative is that they are really proposing a global solution, trying really to provide and to cover all the different aspects which are needed to be covered to reach this transition by using really energy from renewable sources, mainly sunlight and wind, and relying on really the abundant molecules. We need to use CO2. We need, of course, to rely on water and nitrogen, which are the three most available resources on Earth. By using these abundant molecules, really, we can produce fuels and chemicals that can contribute to stopping global warming. And this will be done by storage of renewable energy as fuels, by the production of fossil-free base chemicals for industry and agriculture, and also by relying on technologies which have a negative CO2 footprint. So what does that mean? The first technological approach, which is promoted and recommended by the Synergy Initiative, is to really to rely first on a portfolio of relatively mature technologies, because we have also to keep in mind that we cannot wait for an additional 20 or 30 years before really we start implementing solutions. We need to do it now. And so by relying on these mature technologies for large-scale centralized energy supply and uses multiple steps to produce alternative fuels and chemicals, so especially like water splitting, and relating on PV and wind for the energy supply, this will allow already really to reach a first step. The second approach, which is not so mature at this stage, really takes inspiration from nature, and basically, if you think about it, and I think that was maybe not mentioned from the technological or scientific point of view, but nature is really very, very efficient in translating and capturing the solar energy really to produce materials like wood or whatever, all these biomaterials which are relying on photosynthesis. And so the ambition here of Synergy would be really to develop an artificial photosynthesis process that would really mimic the one which is done on by the nature. And so that would mean that just by relying on solar energy, water, and CO2, we would be able to transform directly into chemical products and also storing energy through chemicals in the form of carbon-based compounds. So these two core activities, of course, need additional, and I have to rely on the development of key enabling technologies, which will be crucial for the large-scale deployment of low-emission technologies. And among these key enabling technologies, you can see that materials is one of the important aspects, really, to develop these different technologies on catalysis, on enzymology, photoenzymology, synthesis, and characterization of molecules and materials. For example, the electrochemistry, computational chemistry, physics, multi-scale modeling, all the digital tools really that can accelerate the understanding, can improve really the understanding of the different fundamental process, how the materials really are produced, but also are degraded, are behaving in the different use. So this is just one example, and you see that here you have this flow chart with how all these can be linked and really can transform totally the way we are today producing the chemical feedstock that we definitely need really to keep our standard of life. One point that I think is important also to keep in mind is that today we are facing these difficulties and that have been highlighted, especially by during the COVID crisis, but also with the recent geopolitical situation with the war in Ukraine. We are more and more aware of the fragility of our supply chains. And it's important to keep in mind that if we want to really deploy all these alternative technologies that need to be put in place, to be implemented really to achieve the goals of this 1.5 degree, the demand on materials will be exploding. That's really what you have here on this slide. Just as an example, you see that for some metals like lithium, for example, which is one of the key metals which is used in batteries, you see that the compared to the demand that was needed in 2020, we can expect an increase from 250% up to 350% in the coming years, depending really on the scenario that either the low demand scenario or the high demand scenario, which can be which have been estimated by the Joint Research Center of the European Commission. So these figures come from this report, the foresight study that was released earlier this year by the European Commission, which really draw our attention to the fact that we are going to face a significant problem if we do not manage correctly the supply chain for these critical raw materials. On the other side, we need also to take care of the fact that it's not only about raw material supply, but it's also about clean technology supply. The supply chains today are fully dominated by China, and that may change only if factory investment quickly take off elsewhere. And of course, all the policymakers around the world are really wielding subsidies and engaging in outward protectionism in a bid to expand the country's manufacturing capabilities. Frankly, we are currently facing a global competition really to localize all the clean technology supply chains from PV to batteries and the hydrogen production with electrolyzers, for example. The trade flows will for sure evolve, and well, the recent initiative like the Inflation Reduction Act in the States and similar policies that have been taken in other regions really are creating this competition and generating for the time being a lot of uncertainty really on where the investment will take place. But that's for sure an issue that needs to be well covered and well anticipated, so that we find a way really to avoid falling from one dependency in another one in the coming years. And at this stage, I would like to mention a citation from Sir David Attenborough, which is saying that we have a finite environment, which is our planet, and anyone who thinks that we can really have infinite growth in a finite environment is either a madman or an economist. So I will invite the next speaker to comment on this one, because I think indeed we are still in a model of this infinite growth, which is probably not sustainable on the mid to long term. Now, coming back to really the core of my presentation on advanced materials. So for sure, the advanced materials are part of the solution. So we need really to develop safer, healthier, smarter, more flexible, more inclusive, and more affordable solutions. And this is true for energy and transport, of course, which are elements or segments of the economy which are really generating a lot of CO2 emissions, but not only. That's just part of the equation, but it's only one aspect, and this needs to be done just by coming back again on my previous slide on the risk we have about this lack of resilience of our economies. We need to reinforce the competitiveness and the autonomy of our respective industries. The good news is that advanced materials are again really on the top of the agenda in the European Union level. So there has been very recently, a few months ago, an announcement that was done part of the Critical Raw Materials Act that was published by the European Commission, which is also announcing a coordinated plan with member states on advanced materials. The aim of this one is really to reinforce the strategic autonomy and the technological sovereignty for Green Deal technologies through a strong, coherent, and inclusive material ecosystem in Europe. Really, that's what they want. What the ambition of this plan will be to target and to develop really material circularity and efficiency. And well, you know what that means about developing by design recyclable materials being less complex, that will be using less critical raw materials, that will be also able to build on secondary sources of materials, and developing the new recovery technologies, for example, or also to develop the system to trace and cooperate across the value chain. Addressing the digital tools really that will be able to act as a game changer by getting a better understanding and better management of all the data about materials. The tools really to accelerate really the design development of materials, and also targeting higher support really for the upscaling and deployment of new materials. One of the issues we are facing today is about really the time to market for new materials, which is definitively too long to versus the urgency that we are facing with the global challenges. And this coordinated plan will be implemented via national and European programs. And one of these programs will be a new co-programmed partnership under the flagship Research Innovation Framework program, the Horizon Europe program, for a partnership with industry, which is proposed currently by the European Commission with the support of the Graphene Flagship and the Advanced Materials 2030 initiative. So I think I'm nearly out of my time, but quickly on this initiative, the Advanced Materials Initiative is an initiative that was launched together with by Emery with 3 other platforms, technology platforms in Europe, really to bring together all the stakeholders along the circular materials value chain, really to develop and to implement this multi-sectorial accelerator that we need really for designing, developing, and uptaking safe and sustainable by design advanced materials that will really allow for this circular economy. So we just released an outline of the strategic research innovation agenda that we will be proposing and discussing with the Commission, really to build this co-program partnership with between the Commission and industry along mainly three big pillars. One will be developing research innovation actions dealing with the development of resilient circular materials value chain. Another one on really developing these tools, digital, but also characterization or modeling tools, and all the methodologies really to accelerate the deployment of the European policy, which will favor the circular economy, and actions around the reinforcement really of the innovation ecosystem to deal with all the required needs also by SME and startups to uptake the technology and to bring this technology quicker to the market. So there is still a survey which is open until the 9th of October, really, to collect all the input from all those who are interested really to contribute to shape this strategic agenda. And it's still time also, if you're interested, have a look at our website. You can find, so the link is here, and you have the possibility to join really the community to contribute to this. And I will stop here. Thank you very much.
Thank you, Philippe. There's some questions in the Q&A which we think might be more appropriate for the panel discussion. So just one quick question, and it goes back to the Synergy project on the artificial photosynthesis technology. How far, in your opinion, is that away from actually a real world deployment, and what kind of scale up is required to get it there?
Sorry, Lorraine, I'm not sure I got you. I got your point. The communication was not so good.
For the Synergy project, you talked about the artificial photosynthesis technology as means of generating materials, and that it's still at low TRL. How far away is that from a real life commercial deployment, do you think? And what's the investment needed to get it there?
Very, very tricky question. Well, I'm not really an expert in that field, but my understanding is that that's still something which is a very quite low TRL activity, and really depending from the specific technologies. But I think that we will still need maybe 10 to 20 years really to see these technologies coming at a large scale level.
Okay, great. Thank you, Philippe, for that. Very much appreciated. And then we move on to our fourth speaker, who is Dr. Ulka Kelkar. And Ulka is the director of the climate program in the World Resources Institute of India. And she's going to bring us back to the economic and socio-economic debate and the impacts of a low carbon green technologies for a large developing country like India. So I'll turn it over to yourself, Ulka.
Thank you very much, Lorraine. I hope you're able to hear me and see my screen.
It's
so
perfect.
Thank you. Yes, I will be presenting a perspective from a developing country, mainly India, where I'm located in the south of India in Bangalore. Just to start with, from the world as a whole, we have about 50 billion tons of CO2 being emitted every year. Out of that 50 billion tons of CO2, 3 or 4 billion tons comes from India currently. Now, as we go forward over the next 3 decades, these 3 or 4 billion tons of CO2 coming from India are projected to increase to 6 billion tons of CO2 per year. It's not a huge increase. And if you can see the bands of yellow and red and green from the electricity sector, from the transport sector, agriculture sector, they're more or less parallel lines, which means that even in the reference scenario, even in the business as usual scenario, the emissions from these sectors are not projected to grow much beyond what they currently are. But the big gray band, which grows wider as we go into the future, that's the emissions from the industry sector. And that's why we call industry a harder to abate sector. Because even in the business as usual scenario, even with current policies, the electricity sector in India is getting quite cleaned up even in this decade. So renewable energy is becoming cheaper because of market forces, and it is becoming comparably competitive with coal. So even in a country like India, which has a lot of coal and continues to use it, the reference scenario itself sees the electricity sector emissions becoming flat in this ongoing decade. So the big challenge is that in 2050, half of India's emissions could come from the industry sector. Looking at the industry sector itself, we see that these big industries, iron and steel, cement, chemicals, petroleum, these are growing fast at 3 times, 4 times between now and 2050. Chemicals and materials in particular, you can see in this chart, The chemical sector is in yellow, 4 times the growth, so that it becomes a fifth of industry sector emissions in 2050. The blue is iron and steel, and the green is cement. And these are really the backbone of India's growth, the construction industry, the materials industry. Just industrial sector growth is very important for the Indian economy. So it becomes a very key challenge to decouple the growth of these sectors, but the growth of emissions from these sectors. Going forward, if we look at emissions from industry, but from the use of fuels, that is the burning of fossil fuels, the use of energy, we find that the emissions from energy use in the industry sector come mainly from the iron and steel industry. That's the blue one over there. You can see over here, it's about the total is going to about 2 billion tons of CO2 per year. But if you look at process emissions, that is the emissions that are generated as chemical processes occur in industry. For example, as iron is converted to steel, clinker is converted to cement, chemicals are made, fertilizers are made. If you see the process emissions, which don't involve the burning of fuels for energy, then the picture changes quite dramatically for India. Of course, this is about 1,000, you can see compared to the 2,000 that you saw earlier. So at the moment, process emissions are a quarter of total industry emissions. Energy emissions are 75% of industry emissions. But instead of iron and steel, the blue band, you see the yellow band becoming important. You see the chemical sector contributing to most of the process emissions for the industrial sector. The green is cement. Now, the good news is that according to modeling that my team has done, in a scenario that is aligned with the Government of India's net zero 2070 target, emissions from the industrial sector can be reduced by 66% compared to the business as usual. So on the left-hand graph, the black line shows you the growth of the industry emissions in the reference scenario without any additional policies, but with a whole suite of additional policies running across all sectors, we managed to create a scenario which is aligned with India's net zero 2070 target, the red line that you see there, where emissions don't grow, they flatten off and then start reducing. And that's a 66% reduction compared to what would have been the counterfactual. If you see over here on the right-hand side, the same story is repeated in every industry. Cement, green, steel, blue, chemicals, yellow. That is, emissions grow, peak, and then stabilize between 2035 and 2040, and then decline thereafter. Process emissions, of course, are harder to abate than energy emissions. On the left-hand side, you see the energy emissions chart, and on the right-hand side, you see the process emissions chart. But the difference is that, remember, in the business as usual, the reference scenario, process emissions were a quarter of industry emissions, and energy use was 75% of industry emissions. Well, in the net zero scenario, we managed to moderate the growth of energy sector emissions. We managed to bring in much more renewable energy, much more fuel switching, much more energy efficiency. But the process emissions still remain harder to abate. And so what happens is that in the net zero scenario in 2050, energy emissions and process emissions in the industry sector become half-half. They become almost comparable. So 50% is coming from energy use, 50% is coming from processes. What are these magic solutions that are leading to that 66% reduction in industrial emissions? Well, we find that the bulk of the emissions reductions, 3/4 of it, can be attributed to 4 main policies. The first and the most powerful in terms of its contribution to emissions reduction is electrifying as much as possible. As much as possible in industry, in industrial applications, we try to electrify. The electricity should come from renewable energy. And where it is not possible to electrify, there should be a switch from fossil fuels towards green hydrogen, which is the use of hydrogen that is itself produced by electrolysis using renewable electricity. This is really the most powerful lever that we find in our model. The second is industrial energy efficiency standards. And this is even more important because it doesn't have to wait for new technologies or new infrastructure to be created. Industrial energy efficiency is a lever that can be deployed right away. It's very important in the short term, in the current decade. Things like green hydrogen, we start ramping up only after 2025, 2030, and so on, because it is really not available right now at scale, even though India has a very ambitious new green hydrogen mission. Industrial energy efficiency is also very important because it actually leads to saving of costs for the industries, because they're saving energy, they're saving costs, so it pays back for itself. It's a negative cost option. The third very important one, and that's what a lot of the presentations today have been about, is about material efficiency, recycling, reuse, longevity. And this is an extremely powerful lever as well for the industrial sector. And the fourth is a carbon tax, which also leads to not just shifts in fuels, but also spurs innovation in new types of technologies and new types of fuels. And we apply a reasonably conservative carbon tax in this model, and it grows over time. One thing I should mention is in the background of this, because it is not a lever specific to the industry sector, but more to the electricity sector, is another policy lever called carbon-free electricity generation. Right now, about 20% of India's electricity comes from renewable energy. 80% of it comes from fossil fuels, which means that even if you electrify, that electricity is still coming from largely from fossil fuels. In the business as usual, in the reference scenario, we find that that share of electricity is growing anyway to 40%. But it needs to become even more. I think 40% by 2030 and 60% by 2050 in the reference scenario, simply because renewable energy becomes cheaper over time. But in this net zero 2070 scenario, even 60% is not enough. We need to go beyond 80% actually in terms of the share of renewables in electricity. So that policy lever of carbon-free electricity generation is really operating at the back end of these four levers that you see in front. So when an industry electrifies, or when an industry produces hydrogen from electricity, then that lever is operating at the back to make sure that the bulk of the country's the bulk of the country's electricity is renewable electricity. Just want to specify over here that just for the sake of transparency, we did not include carbon capture, utilization, and storage as a potential policy lever. We wanted to see how much we could reduce emissions and leave the residual as something that would need to be basically captured. So it's not part of the analysis right now. Now, what does this mean for the economy? Well, first of all, India imports a lot of oil, not just for the industry, but a lot for the transport sector. And this net zero scenario, including changes happening in other sectors, which I've not focused on today, can reduce India's oil import bill in 2050 by $200 billion for that particular year. But as Jacques very importantly pointed out in his presentation, it could be that India, particularly because of its lack of proven resources of critical minerals domestically, it could become dependent on the imports of critical minerals for the scale up of renewable energy, electric vehicles, batteries, and so on. So it is a bit concerning. There is a lot of movement on this. But yes, certainly in terms of the government's balance of payments, this is something that is good for the economy. Let's look at what happens with jobs potentially. India's transition to net zero can generate new jobs in electricity, in construction, in services, and manufacturing. And again, let me just clarify that while I focused in the early slides basically on the industry sector, that back end of cleaning up of electricity, of building up of large amounts of renewable energy, that itself is projected to create a lot of jobs. This is based on an input-output table analysis for the Indian economy. It is not perfect because we don't have dynamic data on how the structure of the economy itself might change with the shift to low-carbon technologies. So it is limited. It gives us a hint of what kinds of jobs might be created in what kinds of sectors. But as you can see over here, the green line shows you that the total number of jobs is projected to increase. The blue line, which is sloping downwards, shows the decline in jobs from coal mining, for example. But the orange line shows you the potential small increase in jobs as a result of new types of manufacturing, could be for electric vehicles or could be for solar panels, for instance. But let's look a little more closely at the manufacturing sector. If we split up the manufacturing sector by different types of industries, a very different picture starts emerging. The blue lines that are all sloping downwards are all showing a decline in jobs in coal mining, in oil and gas extraction, in petroleum refining. The just transition concerns that previous speakers have also spoken about, that in an economy which is currently highly dependent on these kinds of economic activities, there needs to be a proper plan for the environmental actions to also have a good social impact, for workers not to be abandoned as we shift away from these extractive industries. But leaving that aside for now, we also notice a decline in potentially in jobs from emissions intensive materials, so basic metals production, cement production, glass production. We do see an increase, if you see the yellow line sloping upwards, a potential small increase in specialized manufacturing. So moving away from basic metals, but moving towards fabricated metal products and machinery. Perhaps this is as India starts manufacturing more electric vehicles, for instance, or more hydrogen electrolyzers, more electronics and electrical equipment required as the economy grows and has more renewable energy, not just in the supply side, but also electrification of cooking, more air conditioners, more efficient equipment, electrification in industry that we spoke about earlier. So what this means is that when you have material efficiency policies, although they're a very powerful lever for reducing emissions, there could potentially be a decline on the job side. Because if you're making do with less stuff, well, that means you need fewer people to produce that stuff. Unless we explicitly create circular economy jobs, this is not something that will automatically happen by itself. There could be a decline in jobs in emission-intensive materials as a result of these material efficiency policies and carbon tax. And even in the new jobs that are created, they will require the creation of new skills. Let me just move now from these future projections to the current status of the Indian economy. If you see the current landscape of jobs, 70% of Indian industry workers are employed in 10 industries. As you can see, textiles is a big one, so is food products, more than 1 million workers in each industry, also employing a lot of women in these sectors. But going down, you can see that these top 10 include all of the sectors that previous speakers have talked about, where new science and new types of materials are needed. Machinery, chemicals, rubber, plastics, fabricated metals, basic metals, and so on. So these are really important industries from the perspective of jobs. Can we create circular economy jobs? What will they look like? What will working conditions there look like? So let me move on now, leaving aside the charts and moving on to a few case studies from across the country. First, the kinds of jobs that I spoke about are, you'd be surprised to know that most of them are actually located in micro, small, and medium enterprises. They're informal economy jobs. 1/3 of India's GDP comes from micro, small, and medium industries, and they employ 110 million workers. These MSMEs have a lot of potential actually to adopt exactly the kind of industrial energy efficiency interventions that we spoke about. There's tremendous potential, but there is very little capacity, very little access to finance, very little bandwidth, to be honest, to make changes of that nature. And if there are going to be large-scale changes happening, large-scale shifts happening in fuels, in technologies, in the products that are demanded by certain markets, then these MSMEs can be quite nimble. They can pivot, but they will need support. They will need support in the form of skilling programs, in the form of access to specialized financial products for their size, and finally, safety nets, because everyone will not be able to pivot, everyone will not be able to be nimble. There will be people who will not be able to access these skilling programs, particularly women who find it difficult to move out of their locations. And so there will be a need for policy support in the form of social security. I just wanted to mention one program that my organization, WRI India, is part of, which is around building resilient MSMEs. We're working with the auto industry in the south of the country and the textile industry in the west of the country in order to build resilient and equitable supply chains. And we're looking at this not only from the perspective of decarbonization and just transition, but also from the perspective of vulnerability to heat stress and flooding and how to make them more resilient to climate shocks. Another example that I wanted to give was of the brick industry, because there was a lot of discussion about materials today. And it's quite interesting that the brick industry, for example, is something which has a lot of potential for shifting from the current technologies to more efficient technologies. In fact, possibility of blending fly ash from coal power plants. But the brick industry is very much concentrated in the Indo-Gangetic plains, where a lot of the soil is used for making these bricks. One particular state where we're working, the state of Bihar, which is in the north of the country, one of our counterparts, one of our collaborators estimated what it would take if we were to simply try to plant enough trees to sequester the carbon that is generated from the brick industry in the state. The state currently has 6.5 million tons of CO2 emitted every year from the brick sector. And if you had to plant as many trees, sort of on the forest land, you'd require 2% of the state's forest cover to be added every year. And this is a very intensively cultivated, flood-prone floodplain. There aren't enough trees over there. There isn't enough scope. It's very densely populated. So within 10 years, you would pretty much exceed the ability of the state to sequester the emissions that are emitted by the brick sector. So this is something that kind of gives you or just drives home the fact that the need to come up with new materials, new processes is extremely important. Very quickly, we hit the limits of what can be simply absorbed in terms of CO2 sequestration. I live in Bangalore in the south of India, and if you come to Bangalore airport, this is the picture that will greet you at the place where you pick up your bags. These elephants are made not from bamboo, but from an invasive plant called lantana. It looks a lot like bamboo, but it's highly invasive and it is highly labor intensive because you have to uproot it. You can't just cut it out. This particular set of elephants is made by an NGO that is trying to raise awareness about this invasive species and is also working with local tribals to train them to produce furniture and other kind of crafts material out of this invasive species. So basically to incentivize them to uproot and control this particular species. The reason I wanted to show this to you is because bamboo is something that is being increasingly thought of as an alternative construction material. A lot of the airport of Bangalore has it. But I also wanted to say that it's very misleading to only look at these issues from the perspective of just a carbon lens or just a decarbonization lens. It doesn't tell the full story. This picture here tells you a story of biodiversity, of livelihood support, of the need for financial incentives, of the need for skilling. So in all of these kinds of examples, it's important to go beyond a very limited carbon lens. It's also very much possible to go back to traditional methods that we are still using in India. We have not actually forgotten about them. For example, this picture was just taken when I was on my holiday in the same state where I live. Food is served in a restaurant, not on plates, but on a banana leaf. Even now, when we have festivals, we use this. So there is a way to have alternatives to plastics and to not go down the same path as Western countries. But of course, it's not convenient in today's modern life to always use leaves. We all want convenience. We want commercialization. We want practicality. But there is, for example, packaging material being produced by sugarcane bagasse. And this is increasingly being mandated for all home deliveries, for all takeaway containers, for all catering, because the government has a ban on single-use plastic. So there is a possibility of innovating, in some times providing incentives, at other times using regulatory instruments. There are also limitations. For example, in the steel sector, a very important way to reduce emissions and have more efficiency is for India to switch from blast furnaces to electric arc furnaces. But electric arc furnaces need scrap metal, and India, being a young economy, actually doesn't have enough scrap metal to go around. So that becomes a limitation. Perhaps the solution is technological innovation. Perhaps the solution is commercial partnerships. But I want to end with a last point, which is that as we explore the need to have low carbon chemicals, low carbon materials in all aspects, there will be a need for science, basic science and engineering and innovation that is suited to the local conditions. So for example, in India, there is a lot of use of two-wheelers rather than four-wheelers. So any batteries that are used have to be suited for Indian road conditions, for Indian distances and vehicles, but even for Indian weather conditions. So they can't afford to heat up. And there, I think there is a very important and very meaningful opportunity for collaboration between academic institutions, between universities, industry academic collaborations as well. And I think that is something for which the time is absolutely right. And I just want to thank Trinity College Dublin, the Amber Centre, and other partners, other speakers of this event for giving me the opportunity to share the developing country perspective. Thank you, Lorraine.
Thank you, Ilka. Just in terms of a follow-up question before we take a break. So your last point was really interesting about needing the local perspective on deployment of technology. So what sort of incentives or policy interventions do you think are needed to enable that to happen?
I think there would be two kinds of incentives. One, incentives or disincentives. I think a carbon price is itself something that gives a long-term signal to industries. It need not be a very punitive carbon price in the beginning. It could be something relatively small, which gives enough time to industries in India, for example, to get used to. But industries in India are already very much aware of Europe's carbon border adjustment mechanism, which actually hits them much more immediately and potentially much more seriously. So that itself can be a kind of driver of innovation. But on the other hand, in terms of industry collaborations, I think there's very much a possibility of incentivizing small accelerators, small pilots. I mean, for example, for circular economy, recycling of critical minerals from e-waste is something that can be supported, very much right away. So I think there would be different kinds of such incentives. One approach that the government of India is banking a lot on is called the production-linked incentive, which provides a subsidy to a domestic manufacturer. And the ones that have been used very recently are for advanced cell chemistries for batteries. But there have been others as well. And the idea is that it incentivizes not just innovation, but also domestic manufacturing, because it creates jobs, which is important for the government. So these are, I think, some of the examples.
Great. Thanks for that. So with that, we conclude the first part of our session. So I'd like to thank the four speakers we've had again this afternoon for a thought-provoking session. We're going to take a 5-minute break, and then we'll resume at about 17 minutes past the hour for the panel session, which will be chaired by Kevin O'Sullivan, to review some of the points that were made today and to bring the discussion forward. So again, there's some Q&A. We'd encourage you to post some questions, and we'll convene in 5 minutes. Okay, thanks everybody. So we'll resume back now for the panel session. So I'd like to introduce Kevin O'Sullivan. Kevin's the Science and Environmental Editor for the Irish Times. And he's going to chair the panel across the 4 speakers. So please put, we have some Q&A already, but please feel free to put some questions in the Q&A that you want to direct. And I will hand over to Kevin.
Thank you very much, Lorraine, and welcome back, everyone. And just to say to our speakers, I think they have given us a lot of food for thought, and hopefully the rest of the audience will participate and throw in your questions. And I think it's very fair to say that the speakers complement each other well in terms of the issues that they have addressed. So I'm just going to jump in on a few things that really struck me, and then hopefully we'll broaden the discussion to the audience as well. So I'm going to ask my first question to Philippe. And at one level, I was really enthused by the Synergy initiative and all the feeding in of renewables and the chart that you had there with all the future options and not just artificial photosynthesis. But then when I saw your chart then on clean energy manufacturing capacity by location, and it struck me as if there's a huge global imbalance there. And from a European perspective, I think that's very worrying. And maybe you might outline what the strategy is of the EU and trying to counteract that in terms of energy independence and decarbonising its advanced materials sector.
Thank you very much for the question. Indeed, that's very concerning. I'm not in the shoes of the policymakers who are really building the appropriate strategy, but there are obviously, I would say that there was a wake-up call, especially with the war in Ukraine, that really make these topics really high on the agenda of the European Commission and the European Union more widely. Just as an example, if you have a look at the letter of intent that was sent by President van der Leyen in the context of the State of the Union speech that she gave 2 weeks ago, there are only a few very high-level priorities which are included in this letter. I think there are less than 20, and one of these is entitled Advanced Materials for Industrial Leadership. So there is definitively the willingness from the Commission really to develop appropriate policies at the industrial level, research, innovation level, regulatory level, really to bring back or to reconstruct the industry and the value chain in Europe on these clean technologies. There are different announcements which have been done already regarding the Net Zero Industry Act. There is also a new initiative which is named STEP, which wants really to bring more money, more funding, really to support these different enabling technologies and clean technologies. How this will really translate into a coordinated action plan, I must say, I don't know yet. We are. I think we are still waiting a little bit for the upcoming initiatives at the political level. But for sure there is. Yes, I think this. There is. The concern is shared at the very highest level of the member states and the European Union. Yeah.
Okay, well that's reassuring. We might come back to the responsive industry with you and the other speakers later. But I see we have one question. I think you raised the issue of nuclear power, and one question asking, are you talking about rolling out more of the traditional nuclear power plant, or are you talking about going down the highly innovative route in terms of fusion power or smaller reactors? Could you give a quick perspective on that, Philippe?
Yeah. Well, fusion power. I think that's the holy grail, I would say. But probably this one will not be available at scale and really ready for deployment before, I don't know, maybe 30 years from now or something like that. There are some very interesting developments that have been achieved in the recent years, but we still have a lot of challenges to fix. So for the, I think really regarding the contribution to this 2050 target, I think we still have to rely on fission and not fusion.
Okay, thank you for that. If I could turn to Ulka now, and I think our other speakers raised the issue about the huge sums of money that are required for this great transition, not just for advanced materials, but also to decarbonize whole economies. And I'd like to get the Indian perspective on, or the developing country perspective on that, because clearly the amount of climate finance that is being directed to developing countries is nowhere near what's required. So maybe you might give an outline of what's needed in terms of climate justice, in terms of this great transition that we're all going to embark on.
Thank you, Kevin. Yes, indeed, that is something that gets discussed a lot in India. But I would say there are a few different parts to it. The point that you made, and the Indian bit of the global transition, I think is something like a couple of $1 trillion that some modeling studies have shown. The G20 meeting the summit that just got over in Delhi recently, that in fact said that previous figures have said that for the G20 countries there's a need of $4 trillion for the transition, but we want to draw attention to the need for almost $6 trillion. So yeah, these are very big numbers that are being thrown around. A large part of this will be private investment. It doesn't have to come from as flows of government to government money. Much of it will be borne by consumers, for example, those who purchase electric vehicles or, say, electric stoves, or buy houses with improved green building materials. I think the worry really is something that is less talked about, and for which the words that you use, climate justice, become actually relevant. One, there will be a need for funding of adaptation actions in sectors like agriculture, health, water, which are not going to get covered easily by private investments because it's very difficult to recover the costs. These kinds of adaptation actions are not actually covered in the modeling that I presented. The second is the just transition actions that I spoke about when I said that there will be a need for skilling, there will be a need for safety nets and pensions. That has to come from public money or maybe philanthropic money. And the third is that if you recall the saving of the import bill that I spoke about, that I showed, the liquid fuels that India imports, well, India also taxes them. And at the moment, a quarter of the government's tax revenue comes from taxes on diesel and petrol. As we shift towards electric vehicles, this tax revenue is going to be lost, and hence the ability to fund adaptation, just transition, and safety nets and all will go down and will need to be replaced by some other form of tax, which is why carbon tax becomes actually something worth considering. So I think the issue of investment is something which is not as simple. The $100 billion figure per year that that I think should be made up for by sort of making up $600 billion in the coming years is actually very symbolic. It's symbolic of the lack of trust, because this was a small like a baseline figure that could not be met. Negotiations are starting now in COP28 in November in Dubai on a new collective goal on finance.
Is there any indication that countries, and I'm referring to wealthy countries, that they're prepared to give 10 times that amount? Because that's clearly what's required.
Well, if you look at evidence, for example, the recent replenishment of the Green Climate Fund, which various countries announced, then no, there isn't really that indication. For example, I think with the UK, there was an apparent increase in the contribution, but if you look at it in the right currency, there actually wasn't a real increase. So no, recent evidence does not generate much confidence. But yes, so I think a lot of the kinds of actions that will need to be funded will have to come from private investment. But that makes it all the more important for governments, for philanthropies, for even corporate foundations to be very aware of the social implications of these actions. Because if we leave it to the market alone, then certain kinds of actions will get selectively implemented and others won't.
So just broadening the COP28 issue quickly, are you optimistic, given the IEA has said, we're going to peak fossil fuel use this decade, and the UN has echoed this message through Antonio Guterres that we must move to phase down rapidly of fossil fuels. Do you have any grounds for optimism there that the COP will push this on?
I'm always optimistic, not so much from the COP, but from the markets. I think IEA experts have always been wrong in the extent to which renewable energy has actually penetrated various economies, and the fall of, the rapid decline in the cost of renewable electricity. So I think even the IPCC report said solar energy costs have fallen 70 to 80% in this decade. Wind energy has fallen 55% in this decade. So I think market trends will lead to an exponential nonlinear increase. However, also, as I mentioned, even in a growing developing country like India, we see power sector emissions flattening out in this decade. In countries like the countries of the West, the US and Europe and so on, there is an absolute urgent need for them to peak their emissions, for the emissions to start coming down. I think this is something that can be done technologically and financially. I think it needs a bit of political will. I don't know if the COP is the right spur for that. I think there's a lot of brinkmanship that happens in the COPs. But I think the general direction of travel is one that gives me optimism.
Good. Well, we'll hold on to that optimism. Could I ask Michael? Michael, you set the agenda really well, and you indicated the scale of the problem, which is a huge problem, and yet there is some signs of progress. But I'd like to focus in on what you think are the barriers to progress, and particularly at government level. What do they need to get a bigger momentum to decarbonize, particularly energy and particularly advanced materials and chemicals?
Yeah, so let me first answer that, because I was going to follow up on what Ulka said about finance. I think one of the particular problems that we face in that we all hope, particularly in the energy sector, because they're dollar-rich companies, and we all know their recent profits have multiplied several times because of the Ukraine crisis. So we always think of them as cash-rich companies. But the barrier to many of the solutions that I talked about for a company that wants to invest is the huge capital expenditure. And that is always the very last thing that a company wants to spend on, until there's a proven technology and they understand the scale. So that combination of having very ambitious technologies which aren't proven, but the need to scale them significantly is a very, very significant cost. And I think we can expect private sector companies to be involved, but only in collaboration with government in terms of co-support. So I think that's the first challenge, is just the finances in terms of doing this. I think then you have to look, the other barrier that you've got, and I think you addressed this in one of your questions, was that the solutions are horses for courses. So for instance, in Ireland, small island, large area of coast, and so offshore wind is an obvious solution for us to solve our own energy problems in terms of a shift to renewable energy. But I don't know how well challenged some of those assumptions are. And I think this is true, and it's one of the barriers that we have to government support, is if you look at how much energy we consume, how much energy we can make from wind, we probably need several thousand offshore wind turbines. And we don't know what that is going to do environmentally, but we know it's probably going to take up a size of about 4,000 kilometers squared, which is the size of a county. So, that challenge can only be met if it's properly appreciated and there's proper planning and regulation that goes in place. So that's the first challenge is just money, understanding the scale, and how do you develop the funding. The second scale is looking at what solutions best suit your purpose. And the constraint on that, I think, because we're dominated by private sector companies, is the ability to make profits. So if I take the example of the semiconductor industry, 1 trillion chips, that's 1 trillion kilo, that's probably, of the order of 4 or 5 gigatons, big contribution to global warming. They don't recycle one of those chips. Not one is recycled. And the reason none of them are recycled is because they're relatively cheap, easy to make, and generate profit, and significant profits. Recycling chips just decreases the manufacturing, and Ilka talked about this very clearly. The circular economy is a challenge to companies to maintain their profit base. And there isn't a motivation besides regulation which is going to drive them to make those sort of changes. And I think the third thing is that we assume that some of these technologies are ready, and actually, I think as Philip showed, they're not. It's going to take an awful lot of investment from the very basic research level through to translation into functioning devices and functioning plants before we can actually hit them. So I think it's a three-way problem. It's all solvable, but it all takes money.
Well, the figures that you mentioned there are quite breathtaking, really good and bad. But can I just ask you, just in relation to that, two things. One is, given what's required, I have this sense that the public and Marty referred to the citizenry and others, that they don't have that understanding. So that's going to be a major blockage, like in terms of putting up those thousands of turbines off the west coast of Ireland. And also, I think there's a big failure to understand what the circular economy means. And if anyone else wants to come in on that, but maybe, Michael, you just comment on that first.
Circular economy, I think everyone has a concept in their head of reduce, reuse, recycle, which is kind of the three principles. Recycling at the moment isn't really a tractable solution. When I showed you figures for plastics, we're at 4 or 5% recycling of plastics in the world today. The reason is that the oil offsets and the benefits that oils get from governments makes virgin materials, i.e. manufactured materials, cheaper than recycled, and they're also better quality. And there may be technical solutions to that problem. So recycling, we should never think about. We're never even clear when we recycle that we're saving carbon either. Many of the recycling processes you read about are carbon positive, not carbon neutral or carbon negative, which you'd like them to be. So we can't think about recycling. What we've got to think is about extending the use of the materials, either through reuse. So plastic bottles, we don't reuse them because we're fearful of passing on infections, diseases, and microbes, which will cause a problem. But that is a solution, but we're not allowed to reuse plastic bottles, which we just can't afford to have that kind of dependency. And then we've got to make products that are designed to last. So we can't have phones that are designed to fail within 3 or 4 years. Mobile phones, computers have to have extended use, and that's kind of the circular economy. And then at the end, we strip them back and we recycle, and we reuse the components that are in them to the best value. That's really what the circular economy is about.
Yeah, that's
and the only way, just before I finish, but the only way we can measure the advantages of a circular economy is looking at how we're decoupling from waste production and from extraction. And actually, we're doing none of those things. We're increasing our waste production, and we're increasing the amount of materials we extract on a yearly basis.
That's very
But
interesting.
The simple barrier is companies.
Yeah, fair enough. I think Marty referred to all this in terms of a low carbon waste system, and maybe he clarified what he means by that vis-a-vis a low carbon economic system. And I'd like to ask him then after about the urban symbiosis issue as well. So maybe just on the low carbon waste first, Marty.
Yeah, well, what I was trying to get at was looking at the importance of the afforestation, the planting of trees. By not wasting carbon, you're using the tree to sequester it. So I think some of the thoughts about the difficulty of making that transition, I think we can go as far as we can, but at some point it's going to be more about let's try to reduce what we're wasting. And I think Mick just pointed to the difficulty of like plastic. So that's really what I was getting at. I think trees are like a stepchild kind of thought, and I was serious about the question of why isn't there a afforestation annual conference of world leaders? Because to me it suggests that all this talk about low carbon economy is about social control. And
yeah, very interesting point. Very interesting point. Related to that, we have a question from one of our audience about the need for very large land areas for renewables, vis-a-vis or competing with the urgency for afforestation. And like, how do you balance that? And obviously, the land use issue is still very much up in the air, and then you have food production competing with all of that. And how are we going to get that into the right carbon framework, do you think, Marty?
In terms of land use, well, I think there's plenty of areas in the United States that could be afforested. I think if we immediately came into an understanding that urban sprawl is something to stop and reverse and try to make cities more dense. In order to do that, it requires all those tangible and intangible assets that I was talking about. And, then that leads into where do we get the revenue for that kind of density? And I mentioned land value taxation and relieving taxes on income and capital. So that's really what I see as the need. And I think when we get into these public meetings about, hey, this is the big picture, here's where we can make some strides, here's where we need some time, I think there needs to be some serious talk about certain options, and there should be some some serious question. For example, Philippe talked about nuclear power. I think that with the forecast for what we would need in electricity, I think there's a lot of people in Germany and the United States that need to get over their irrational fear of nuclear power, because without that, we're not going to get anywhere close. So then the question is, if we don't do nuclear, then are we really serious?
Yeah, so that's a good question to come back to Philippe with. Clearly, Germany's got out of nuclear power. Is it realistic to assume that Germany will sort of get back up on that horse, given the way the world is now in terms of emissions and slowness in terms of decarbonizing? So do you have a view on that?
Well, it's a difficult question. I think the debate was totally polluted in Germany by the Green, who were really mismatching a bit of everything between nuclear bomb and nuclear power, and so the nuclear was considered as really being the devil energy, and so it's I don't know. I'm not following really what's happening in Germany in that field, but I would be surprised if really the society would be ready to come back to something which is more neutral and let's say scientific based. You know, when the debate has been really tented and really has been totally deviated from the scientific reality, it's very, very difficult to bring back things to a non-emotional debate, I would say. So
Okay.
I don't know. Frankly, I don't know. It's just guessing, and I'm as I was mentioning, I'm not really following this discussion attentively.
Fair enough. Just on the issue of electrification, which you raised, it seems to me that it's very obvious that electrification is a big part of the solution, not just in energy transition, but also in advanced chemicals and materials. But there's no sign of big international cooperation at the scale required. I think, you know, countries, particularly member states of the EU, are stuck in their silos and they don't see the need for a supergrid, for example. Do you have a view on that? Because clearly it's one of the really big levers, isn't it?
Well, there are some positive signs. You have some collaborations between different countries. For example, Denmark, the Netherlands, and Belgium, if I'm not mistaken, who agreed really to have this windmill offshore in the North Sea. There are some other projects also ongoing in more in the southern part of Europe. So it's not yet at the EU-wide scale, but things are moving, and I think there is a lot also of initiatives which are conducted currently by DG Energy in the Commission, really to try to have things moving in that direction. But indeed, there is still a need. Well, I think the transformation of the energy distribution sector is definitively part of the equation that needs to be tackled. Also, it's not only about generating renewable energy; it's also about distributing it. And one of the big issues, of course, is the fact that most of these energies are intermittent one. So you need really to go for these collaborations and really opening really the national production, so that really you can better smoothen the variation that you will have in each country.
And it seems to me that there's similar issues in relation to hydrogen as well, that you know, hydrogen could become the big international fuel complementing renewables in terms of wind and solar. But the analysis I'm sort of hearing as an outsider looking in is that the costs around hydrogen are prohibitive, and that almost it would be reckless to scale up hydrogen production in certain scenarios. Do you have a view on where hydrogen fits in and on the cost issue?
I don't have the figures in mind, I must say, but indeed, it's true that the green hydrogen really technologies are still significantly higher than the more classical hydrogen generation, which are not so green. I think that it will the extrapolation of really by improving the different technologies which are involved there, and also by the optimization of the cost, by creating really this technology at scale, will significantly reduce the cost of this electrolysis aspect, electrolysis technologies, and so on. But there is still a gap. That's true. There are a huge expectations and really a lot of efforts which are conducted at the EU level really to develop these technologies, and things are really moving in the right direction. But I must say I've not looked at the remaining gap for a while, so I cannot. I don't want to mention figures.
That's no problem. Maybe I'd ask Olga to give a developing country's perspective on hydrogen. She mentioned it earlier. Is India making a big bet on green hydrogen?
Yes, that's right, Kevin. I think one of the motivations for that is because on the solar front, India did not invest heavily in domestic manufacturing of solar panels. So while it has benefited from the decline in costs as a result of economies of scale in China, it feels that with green hydrogen, it has the opportunity to be an early mover. However, there are a couple of things related to this. One is hydrogen is not easy to transport. So there is a need to co-locate units that will produce green hydrogen and those that will use it. So there is mapping going on right now about the possibility of co-locating, particularly next to fertilizer plants. Related to this is the idea of converting, of having green ammonia as something that can be transported more easily rather than green hydrogen. A third related issue is the regional grid that you spoke about for Europe. Well, there is discussion of that from the Middle East, to Southeast Asia, having not just solar power but also hydroelectricity from the mountains of the Himalayas, so that as the day progresses, you have kind of solar or hydro or being generated. But the issue of storage is very important. For several months of the year, we have the monsoon, when solar production might be reduced as a result of cloudy skies. Wind power itself has been affected a lot. There are studies which show that wind power generation fluctuated by as much as 40% in a certain July a couple of years ago, because wind speeds were lower than average during the monsoon. So not just daily storage, but also seasonal level storage is something that's very important. Linked to this is the issue of land use that one of the earlier questions referred to. That is, if we need to generate renewable energy on the large scales required to produce that green hydrogen, we are competing in India not so much with forest as with agricultural land. And from a farmer's perspective, a farmer who's having to deal with the vagaries of the weather, whose land is rain-fed, drought-prone, actually selling or leasing your land to a large-scale solar park might actually give you a stable income, almost like a salary, rather than having to wonder if this year's crop will be good or not. But what it does is it prevents landless laborers who depend on agricultural labor for their livelihood from accessing that land anymore, and they have no choice but to migrate. Pastoralists also lose access to their grazing grounds. So I think, again, here there is an opportunity for pilots. There are demonstrations in countries like Australia, but I think also in the UK and the US, on agri-photovoltaics, that is the coexistence of solar panels, sheep rearing, possibly vegetable farming. And I think that is also something that needs to be very seriously considered for countries like India. Thanks.
It's a very interesting example. Could I just ask you, while you're on there, about the coal situation in India at the moment? There's some indication that India is, relying too much on coal at the moment, and it's possibly even scaling it up. But your charts show a progression, a downward progression. Maybe just give us a quick update on what the situation is there on that.
I mean, the situation is very simple that the faster we can scale up renewable energy, particularly solar, the faster we can scale down coal. I think from the West, particularly, you know, when you add up big numbers for the big country like India, everything looks you know, sort of alarming at times. But the picture over here is much more nuanced. Even thermal power corporations, those actually owned by the government, are diversifying their portfolio and are committing to becoming net zero by 2030. The Indian Railways, which has always used a lot of coal, has committed to become net zero by 2030. The National Thermal Power Corporation is, you know, is investing in a lot of renewables. The issue is that certain states in the country, certain regions, are highly dependent on coal. The entire economy needs to be diversified, and this is not something that can happen overnight. So that's why many of these states, for example, Jharkhand in the center of the country, have actually set up just transition workforces and committees and are seriously looking at the issue of, if you close down coal mines, how can you restore the land in a way that creates new jobs? So I think definitely over here there is, I think the general direction of travel is one of optimism. The renewable energy capacity in the country has already crossed 40%. And this is projected to become 60% by 2030. So, yeah, I mean, usually when I speak with journalists from the West, the first and typically the only question is about coal. I'm so glad you saved this question for last, didn't start with it. But yes, one of the things that I try to do is to say, yes, it's very important, but there is much more happening. And and I don't think anybody wants to hold on to a dirty, polluting fossil fuel that creates local air pollution as well. The challenge, of course, is to make sure that that people also, you know, their livelihoods are also protected.
So all of the speakers have highlighted the scale of what's required, and you know, it's fantastic with, you know, the ambition and what's envisaged over the next coming decades. But you yourself raised the issue of jobs. Do people in your country see the opportunities that are there in terms of new jobs, new training, you know, a different way of working? Is there buy-in for that?
I think there is definitely a lot of high-level spotlighting of that. Every year when the finance minister announces the union budget, green jobs, green industries are always highlighted in the last 2-3 years as a driver of growth. Whether that optimism actually holds out is you know, other speakers have, of course, put a note of caution. But I think, again, over here, the details matter. If there are new green jobs created, will women be able to access these jobs? The Maharashtra State Electricity Department, for example, has a target that as it scales up its renewable energy, 50% of the new electricity jobs, you know, what are called linesmen, should be women. And that is something that takes explicit and deliberate action. An electricity utility can be gender neutral, but if it makes a deliberate effort to have a policy like that in place, then I think that is something that bodes well. Otherwise, yes, green jobs may be created, but the underlying inequities may still persist, and we may get a low carbon transition, but not necessarily a just and equitable society.
Okay, thank you for that. Could I ask Philippe about that in the European context? It seems to me there is a huge demand for jobs and career diversification. It's going to happen like never before, but a fundamental question: are we building the right skills pool? Is it sufficiently large? Is it sufficiently diverse in terms of the transition that's required in Europe? Like, are we creating the pathways, retaining people, training them adequately, and getting buy-in for that?
Well, I think the topic is also high on the agenda of the policymakers, and there is definitively, this one is definitively also well captured in the a priority really to be tackled and really for example in the battery field that I know a little bit better than others. There is now really a coordinated effort which is conducted with InnoEnergy, which is one of the kicks of the European innovation and technology organization that really is offering as a kind of a platform with a lot of trainings and and really courses really for training the different categories which need to be trained on battery technologies, really from researchers and engineers really to blue collar workers, so that really they are by really consolidating all the resources which are available in the different countries. They can really also offer the best really the training that which suit the best really the needs from the different industries and academics. So there is a lot of initiatives which have been working on identifying what are the gaps, what are the needs from industry, what are the needs from research, really to tackle this. I think there are still some important needs really to integrate the sustainability criteria much more in all the education courses for engineers and all these technology careers. This is something which is still not enough included and integrated really in every course that the new researchers and the future engineers need really to fully integrate into everything they will be conducting and all the projects they will be leading in the future. So I know that I think this year was one of the education was really one of the big initiative that was also coordinated at the European level. I heard about some new initiatives, new programs which are under preparation, or again also probably deployed by the other kicks of the EIT, notably in the field of raw materials, in the field of advanced materials, digital technologies, really to support all the deployment of these renewable energies and how to manage and to capture and to better understand really what is the urban mining, and to understand when these resources will be again available on the market. There are a lot of initiatives which are under preparation in that field also.
Very good, thank you for that. Maybe I could ask Marty for an American perspective on that. Is the transition happening there in terms of work, in terms of the benefits of the Inflation Reduction Act in America? I'm conscious of the auto workers' strikes at the moment and the issue about the future of the industry. So maybe you could give us a quick overview of where you are at in the United States.
Okay, well, I'm in New York City, so I mentioned the city's effort to de-fossilize the economy by forcing large co-ops and such to get away from natural gas and getting rid of their gas heater. So New York City is the first in that type of effort to force a decarbonization. In terms of the recent infrastructure bill that I guess it was titled anti-inflation, I think there's a lot of money going into green energy and other types of infrastructure. I really don't have a sense of how fast that's going, because when you talk about infrastructure, you often talk about years of planning and then construction. So I would would guess that we're probably 5 or 10 years away from really seeing the impact of that investment. But it's good anytime you place money into infrastructure that might cause cities to be denser, and we get away from urban sprawl. But the economy kind of supports that business as usual, which is it's unfortunate. But I think it's a positive thing that the auto workers are on strike to get a fair percentage of the value of the cars that are being developed. It's a question of how long that agreement is going to last, and it should be recognized that the only reason that they got the ability to strike is that a lot of the production has come back to the States as opposed to in China and other offshore type construction. So that's kind of like my quick perspective of the United States. I think Mick really summed up the challenge that it's not going to be by the private sector. I think whatever the Anti-Inflation Act did, I think if we're serious about the decarbonization, I think there's some really hard decisions to be made. And I haven't heard any candidate running for president of the United States in 2024 really getting into that discussion.
Yeah, probably too early. But it goes back, I think, to your earlier points about urban areas. I think there's a lot of evidence in the context of the United States that cities are leading the way. It's not fair to say. You can pick out some very obvious ones, New York, a number of cities in California and elsewhere. They see what the benefits are and are pushing on regardless. Is that a fair summation?
Yeah, I do see some pushback, like in my case, in my building itself. That's the one where we're being forced to accept all electric power without knowing what that power is going to cost. And like I said, the debate about how much of the CO2 in the atmosphere is coming from man-made sources is still open for debate. So having a resilient path where we still have access to natural gas seems to make a lot of sense. Now, maybe they could do something so that maybe we would use less of the natural gas, but I think just having that service seems like it would make a lot of sense socially. But yeah, I think you hit the nail on the head in terms of where the change is going to happen, and it's probably going to be on the local level.
You, at several points, raised the issue about meaningful community engagement, and it seems to me, as a skeptic, there's a lot of greenwashing out there by businesses, and the consultation on major projects is tokenistic at best. But do you believe that the meaningful engagement at community level can really drive the transition?
Yeah. Of course, there's always going to be greenwashing. I mean, that's kind of like the definition of the private sector and the people trying to make a buck on whatever they can say. But I guess what I'm talking about when I talk about community engagement, the standard that I helped develop, the E3210 from ASTM, it's really kind of like a game changer in the sense that it takes somebody like a mayor to say, I'm going to be honest about this. I'm going to convene the people that elected me, and we're going to look at the numbers. How much we spend, how much it's coming in, what's our performance, and if they don't perform, it's only like every 4 years you get somebody else in. So I guess that standard it has yet to be adopted widely, but it gets away from this typical community engagement event where the leaders know what the answers are. They get up there, they talk, and then everybody goes home and nothing ever changes. That's what I'd hope to change, because there's a lot of cynicism.
Yeah, that would be progress, I have to say. Anyway, we're coming to an end, but there's two questions I'd like to ask all the speakers very quickly. And while you're on, Marty, you can start first. And I think all of you referred to the Sustainable Development Goals, but the latest UN report at the General Assembly was very dismal in the sense that we're considerably behind on implementing successfully at least 7 of the goals. And like, clearly there's a problem there. What do you think is the problem, and how can we make more progress across the SDGs?
Across all 17, you're saying?
Yeah.
Well, it takes a committed electorate, I suppose, to demand that. It's not going to be dictated to by the World Economic Forum or the United Nations. I think some of the things that I mentioned about having denser cities and how to get denser cities is definitely a way to start. I mean, if a state wanted to implement those kind of development goals and look, how many do they tick off of the list?
Yeah.
They have denser cities, you'd see probably about 5 or 6 at least in terms of the poverty.
Very interesting example. I think that would tick a lot of boxes.
Yeah. So that's what I'm thinking, is that if the states would get serious about urban environment, there's a lot of talk about security and policing and healthcare and all these education. All those are all in several boxes there. So the states, I think, in the United States anyway, have a large role to play. Okay,
thank you. Michael, if I could ask you, from an Irish perspective, we seem to be very slow on a lot of the goals. Do you have any view on that?
Yeah, I do think that one of the major problems with the UN goals is that goals that aren't linked to deliverables. And I think you can only have deliverables if you have good standards. I think Marty would support me in this. And we don't have any of those standards, or so few of them, that we can't drive the goals because we don't know what the deliverables are. And even if we do know what the deliverables are, we can't measure them.
Right. Yeah.
So, we're working with figures which many times are guesstimates, and many more times probably greenwashing, as you alluded.
Right. Philippe, do you have a European perspective on that? Clearly, Europe is making progress in a significant number of.
I'm not sure I have a European perspective. I have my own idea or input. I think that, well, when we are talking about this transition, which is needed really to tackle the climate change challenge, it's a multiple equations with so many different unknowns, and so really being able to make sure that when you will be moving in one direction, that will be obviously making one goal to progress, that you are not reducing or going backwards on other goals. I think that's not that obvious, and so that's why I think it's so important to bring together really the diverse experts from the different perspective, and not let just one one particular community really leading or pushing for what they believe are the appropriate solutions, but really to have to really to bring together those who will be also coming with a different perspective on the societal challenges and not only technology. So we need, I think, one thing that maybe was not a lot emphasized is that technology alone will not solve the problem. I think that we need also to change culture, to change behaviors, to change really the way we feel or we consider that what progress is. And yeah, that's much more complex than just following KPIs on performance of technologies.
Yeah, thank you for that. It's a really interesting observation on how we might progress. Olka, do you want to comment from a developing country perspective?
Yes, I think we have made progress on things like reducing poverty, improving education-related indicators. I think where we are lagging behind is on aspects of air pollution, water pollution, clean water, and biodiversity. And I think over here, I'd like to highlight two issues. One is the need for greater enforcement. There needs to be an improvement in the capacity to monitor and ensure compliance. A lot of this happens at a very local scale, and the capacity is very limited, but also businesses need to be held accountable in terms of their impact on the environment. The second aspect, and this is slightly more of a governance issue, is that often issues of air and water, the jurisdictions are administrative divisions, but the airshed or the watershed cuts across these administrative boundaries. And I think that becomes very much an issue that becomes harder to monitor and to tackle. The third and final thing is just the fact that there are limited choices often, and that's why trade-offs and compromises are being made, some of the sorts that we discussed today. And the worry is that, as we go forward, if we have a very carbon-centric lens, then there will be more compromises made. And unless the engagement of the affected communities is ensured, some of these issues might get worse.
Thank you for that. That was really helpful contribution. And I'm going to finish now. And again, I'm being slightly skeptical here, but I want you to counteract that. I'm looking in at all this requirement to transition and to address climate and to decarbonize. And I observe when push comes to shove, to use that expression, there's little appetite for system change. It's too expensive, it's too troublesome, and we're doomed anyway. So is there something you can say that will give us a little bit more hope? Is it doable? And I'd be very interested in a quick view on that. So I'll start with you, Olka.
Is it doable? Well, it has to be done, I guess. I think change happens slowly and then all at once. A lot of systems have changed in my own lifetime, and when it's the information technology or education technology, so many things. It is possible to do it. I think that when we started making the model that I showed you, we were told that our electric vehicle assumptions or our green hydrogen assumptions were just unrealistic. And by the time we finished making the model, this is over a period of 3 years, we were told that our assumptions were too conservative, that policies that would be part of the business as usual scenario shouldn't belong in the net zero scenario, they should belong in the reference scenario. So yes, change does happen. The point about systems thinking is a very, very important one, and I won't sort of be flippant about it. Our governance structures are not set up in a way that is conducive for systems thinking. But yeah, I think success breeds success, and the more examples we can share, the more optimistic we can be, and it can spur greater ambition.
Thank you for that. And Marty, if you want to come in with your view.
Yeah, I guess I'd like to turn to one of the people I mentioned in my talk, Kate Rayworth, who wrote a book called Donut Economics, talking about the safe space between the excess and the safety net, I'd say. And I think that social equity requires that we say forthrightly, this is what we're about to do, and this is what's likely to happen to you, and you know, not hide anything. I think that's the secret behind what her concept was, is that we say, well, here's the safety net that we're going to put out, and we're going to limit the excesses that are causing damage, whether it's pollution or other things. I think that's the approach, and we just can't shy away from it. We just can't say that you know, that's life, you know.
Yeah. Well, I like that injection of realism in it as well. Okay, Philippe.
Yes, well, I think we have no choice. We have to go and we have to make this change happen, and we are doing it, frankly. And just building on what Ulka was saying, I remember 5 years ago when I really became very engaged in these discussions. The plan that were announced for batteries and for electric vehicles, well, most of the people were just laughing at it, and we are going to make it, and this is probably the most important change that will be conducted in less than 20 years. So and this is just one example, and I think that by really aligning and making sure that we have a consistent approach between really the regulatory aspect, the strong alignment between industrial strategy and R&I policies, we can really make this change really becoming a reality and being persistent. So, yeah, I think that's, well, I can't remember who was showing this slide. I think it was you, Mike, about really the evolution and the generation of the CO2, which is also very much showing the acceleration of the speed of change, the industrial revolution. I'm sure that if we go back to the 17th century, no one would, well, we are, for them, we are living in a science fiction. And just thinking of our grandparents, what they have been just experiencing as an evolution, it's crazy. They just keep in mind that I think what if they came on us maybe before the First World War, and they died or they are still alive, and so just see the change and the progress that has been conducted, with indeed some challenges that have been linked to this this evolution. But I think that, yeah, we have to trust in mankind really to be able to also to solve the problem that we have been generated in the last years and also the last decades. Yeah.
Very good. Yeah, I think it's been a remarkable transition when you put it like that. I'm leaving the final word to Michael then to close this panel discussion, and we'll hand back to Lorraine then as well.
Yeah, I guess I oscillate between being hopeful and absolutely unhopeful. But in the end, I always verge on the hopeful, if only because in the last 2 years, we've seen the effects of climate change. More than any other time, even 3, 4, 5 years ago, you know, it was something theoretical and something we could argue about. But I think the effects that we're seeing make it really plain that we have to do something. And I think that's the greatest motivation that we have. So in retrospect, I'm more hopeful than not.
Very good. That's our cue to end with hope. So thank you very much to all our speakers, and it was really stimulating discussion. And I think There's some great messages there in terms of how this can be done, and not just about all the problems. So thank you for that. And I'm going to hand you back now to Lorraine.
So thanks, Kevin, first of all, for chairing the session. I think it was a really thought-provoking afternoon, and thanks to all the speakers again. It comes back to the idea that the necessity to decouple economic growth from materials consumption is a classic wicked problem. But I think what's coming out of today is that it's a global issue. And as Philippe said, it's technology is not going to solve it alone. It's going to need the intersection of, as we've seen today, science and technology, social, economics, community engagement, and policy. I think it's encouraging that the UN are putting an emphasis on this. It's going to take something like that, I think, to address it. So I'm also oscillating between hopeful and worry. But I think, again, the points raised today, I think, will go far to start progressing that out. So thanks everybody for their attention. On behalf of the Amber Centre, it's been a great opportunity to do this, and hopefully people have got something out of it. So, Mick, if you want to add anything else?
Yeah, I just probably want to say is that we probably all remember that this is a new area of expertise. It is so multidisciplinary, it's so translational between areas that the kind of 100 years and 200 years of research behind these topics don't exist. So this is very much the frontier, and we've got to remember that we need to build that expertise so that we can inform proper policy. That's my kind of closing remark. And finally, I do want to thank Kevin and all the other speakers and all the contributors, because I think this has been a really brilliant discussion, and I hope it will catalyze more meetings like this where we bring the people together that I think Philip talked about and Marty talked about, that can bring that accumulated expertise to meet these really serious challenges. So thank you very much.
Great, thank you.
Thank you.
Close the session on that point.